Article 100 definitions. When it comes to definitions, obviously there are lots of things that we use as far as terms go in the electrical trade. Some things are common, some things aren't so common. However, oftentimes the things that we're talking about may have a different meaning to us than what they mean in the code. So when it comes to Article 100, it is intended to give clarity to words that are fairly foundational or essential to understand when interpreting the NEC, but it's not designed to include definitions that are going to be for commonly used words, unless the commonly used word is one that's commonly misinterpreted or misused. If the NEC doesn't define a term that you're looking for, well, it's okay to get that clarity from another code book or a dictionary or a trade book of another sort that's going to be acceptable to your inspector. Now, this happens quite a bit. Not every definition is going to be in the electrical code book, but you'll be able to find it somewhere. Give you an example, the difference between a dwelling unit bedroom or a sleeping room. Those things can have distinct variances, and you'll be able to find definitions to them in several of the different books. But to narrow it down, the sleeping room, you're probably going to have to look in the building code. Accessible, when you're talking about equipment, allowing a close approach and generally not guarded by elevation, locked doors, or anything else. Accessible wiring methods, not permanently closed in by the structure or the finish of the building, and they can be taken down or removed without damage to the structure. Readily accessible. This is a pretty common example. We see this often, not only in our houses, but also in laundromats and public use facilities and multifamily dwellings. You can see there's a plug-in right behind that dryer. And in looking at that plug-in, do you feel that that would be readily accessible? In fact, looking at that electrical panel over the top of the counter, do you feel that that would be readily accessible? Code says in order to be readily accessible, it has to be capable of being reached quickly without climbing on or over obstacles for the purpose of inspection or energizing or de-energizing or for service. And one of the additions to the code in 2014 also says that you can't consider it readily accessible if tools are required to access it. If you've got a multifamily dwelling unit and your equipment's located on the second floor, it can still be considered readily accessible as long as it meets these requirements. So it doesn't have to be on the ground level. Ampacity. Ampacity is the maximum current in amps that a conductor can carry continuously without exceeding its temperature rating for the application it's being used in. Appliance. Equipment other than industrial that is normally in standardized sizes that is designed to perform one or multiple functions. This could include a furnace, a stove, or a dryer. Approved. Acceptable to the authority having jurisdiction, usually the electrical inspector. And of course we abbreviate authority having jurisdiction with AHJ. Always discuss any changes or alterations or special methods with your AHJ. arc fault circuit interrupter, or AFCI for short. A device that's intended to provide protection from the effects of arc faults. So what are those effects? Well, a lot of times it's going to be heat that will lead to fire. If the arc is recognized in the circuit and is de-energized, of course, it's going to get rid of that fire hazard. As we spoke about in several of the other chapters and several of the other courses, we got two things we're looking at here in the electrical code. Two things that the code basically surrounds. Don't kill the electrician. Don't burn the house down. Hey, what makes an arc fault circuit interrupter different than just your regular run-of-the-mill $3-4 breaker? It has a chip. It has a chip inside of it that recognizes the characteristics of an arc fault. And we'll come back to that. Here's an actual arc fault breaker. Notice the neutral pigtail that comes off. The one thing that is different about an arc fault breaker from a normal breaker is both the hot and common will hook up to this breaker, and then the neutral will come right off of the breaker here with this pigtail to a neutral bar. Here are some other examples. Now, in the clear example down here in the middle bottom, you can actually see the chip that's inside. Some of the guys will complain that you get more neutral or nuisance trips with an arc fault breaker. That's not necessarily the case as time goes on. The longer time goes on, people can turn in problems that they're having with these breakers, and they can program that into that chip and make it a normal scenario if they can reproduce it in a lab. Similar things have happened in the past with GFCIs. Attachment plug. A device, when inserted into a receptacle, establish a connection between the conductors of the attached flexible cord and the conductors connected permanently to the receptacle. Bathroom. An area, not just a room, an area including a basin and one or more of the following. Could have a toilet. How about a urinal? Or a tub? Even a bidet has been added. Bonded. Connecting conductive, potentially current-carrying objects together, make sure that they don't have any difference in potential. Now, when it comes to bonded, grounding and bonding is a big section of the code book. Always remember, bonding is connecting stuff, whereas grounding is connecting to the earth. Here's some examples of bonding. Again, connecting conductive, potentially current-carrying objects to make sure that you have good connectivity and conductivity. Notice the bonding wires going from one pipe to the other, and both the copper on the left and the gas pipe on the right. Bonding conductor or jumper. Maintains electrical conductivity between metal parts of the electrical installation. Notice in the picture that we've got a jumper because it's It's possible with the flexibility of that jumper, it could go from one spot to the next on just a regular stationary fixed in place device, but you also could have something there that may move a little bit. It may shift, expand, contract, vibrate. Oftentimes you'll see that on devices that have a flexible bonding jumper like that. Main bonding jumper. Connector that ensures continuity between the grounded circuit conductor and the equipment grounding conductor at the service. These could be a screw, a conductor, or a strap. How many are there on each system? Only one. That's why they call it the main. If you have more than one main bonding jumper, because you're connecting several panels into one system, you'll need to disconnect all but one of those main jumpers so that you don't create a current on the metal parts. Branch circuit. Conductors between the final overcurrent device, like the breakers, and the outlets. This would start at the breaker and end wherever the load's connected. Multi-wire branch circuit. A branch circuit with two or more ungrounded conductors having a voltage between them. Okay, here we got the red and the black, with an equal voltage being between the ungrounding conductors and the neutral conductor. So notice in this particular example, looks like we've got a 240 volt breaker, and with that we've got a hot leg coming off each side going to, black one goes to two different receptacles, red one goes to one receptacle, but they share a common or a neutral. So the days of seeing this often are going to go by the wayside at some point, at least for the time being. It's not frowned upon, it's not an illegal installation, but until we get under wraps the arc fault breakers and the GFCI breakers that need to be installed in many of the areas where these already exist, you're going to start to see them fall by the wayside, especially in the new construction. Existing homes, they're there and they're probably not going to go anywhere for a while. However, the more you need to hook up the GFCIs and the arc fault breakers, the more you're going to see just regular single circuits like is a traditional way. One of the advantages you get from a multi-wire branch circuit is obviously, as you can see from the example, you would have the potential to use less wire, and you would also have the potential of running multiple circuits off of just one breaker. So you can do a lot more stuff inside of that panel. However, the downfall on that is what happens if they were to lose the neutral or possibly one of the hot legs. Now, if somebody comes along and takes off the neutral, which wouldn't make any sense, obviously you would stand the chance of overamping everything else. So you could possibly create a circuit from the one hot leg completely through the loop to the other hot leg. Now you might ask yourself, why in the world would we ever come along and just remove a neutral? That's an unlikely scenario. Most likely you would probably see the power utility lose a neutral, maybe a lightning storm, maybe some kind of a surge or something like that. If the power utility loses their neutral, it would do virtually the same thing. Circuit breaker. A device designed to open and close manually at a set or predetermined amount of overcurrent without damaging itself. There's several kinds of breakers. There's adjustable, instantaneous, inverse time. Each of these have different requirements as far as sizing them for the circuit. and we'll talk about those in a later course. Clothes closet. A room intended for the storage of garments. It's not intentionally habitable. I'm not exactly sure how you would accidentally end up living in a closet or sleeping in a closet, but I assume they wouldn't put it in the code book unless it's been an issue at some point. And if you look at the closet on the left, that's probably bigger than my family's first apartment. Communication equipment. Electronic communications equipment responsible for video, audio, and data transmission, as well as the tech support equipment like laptops. It also includes the conductors used only for the equipment operation. So the conductors that you would use to tie the equipment together, even though they don't go to another device for origination, those would still be considered part of the communication equipment. Concealed. Wiring that is not accessible because of the structure or finish of the building. Now, this brings butterflies to my stomach every time I look at it. I look at that plaster and lap board. Took some craftsmanship to make that stuff look great, and it always does look great, but boy, they just don't build it like that anymore. Literally. Have you ever tried to take down plaster and lap board before? Whew. Damage would occur if repair or replacement were needed. Continuous load. A load that's expected to draw maximum current for 3 hours or more. Controller. A device that controls the electric power delivered to electrical equipment in a way that's predetermined. Oftentimes you're going to see a controller that will be outside of the area where it's actually controlling the device or the motor, because oftentimes the area where that device is may be a hazardous location. It may be um, a basic principle of wanting the on and off and actual control of the unit to be at a lower voltage than what the actual fan or motor or device runs at normally. Maybe we don't want our guy out there pushing a button or turning a switch that has 480 volts behind it. We would want something more manageable at a much smaller amount of power, like in a controller. Device. Components of an electrical installation other than the conductors. Its intent is to carry electric energy. It includes receptacles, switches, breakers, and fuses. All of these are devices. Dwelling unit. Must provide permanent fixed methods of living, sleeping, cooking, and sanitation. It's a single unit that has independent living facilities for one or more people. If there were more, we would call it a multifamily dwelling unit. Here are some examples. Multifamily dwelling unit. A building with all of the same requirements as a single dwelling unit, but has 3 or more dwelling units in it. Apartments are a great example. Effective ground fault path. A path designed to, and intentionally installed to, provide a low impedance path from a ground fault to the supply source in order to make sure the overcurrent device or ground fault detectors are able to remove the power as they're intended to do. What does that mean? what literally is an effective ground? Why do we gotta say effective ground fault path instead of just calling it a ground fault path? A ground fault path is there just because. An effective ground fault path is one that you put there on purpose as part of your electrical system to make sure that a short that happens on the side of my house doesn't just sit there and energize the electrical parts outside. It actually will make it back to my breaker and trip the switch so that it cuts the power. It's one that's put there on purpose. That's the difference. Electric discharge lighting, EDLs. Lighting systems that utilize neon tubing or high intensity discharge lamps. Equipment. General term used to describe items used in electrical installations like machinery, luminaires, appliances, fittings, and devices. Exposed wiring method. On or attached to the surface or located behind access panels. Generally speaking, this goes back to the term accessible when we talked about at the very beginning of the course. It can be removed without real damage to the structure. Feeder. Conductors between the service equipment or any other power supply and the final branch circuit overcurrent device. Ground. The earth. That's all we're talking about when we ground something, making a solid connection to the earth. So when you run grounding and bonding together, they don't mean the same thing. Bonding is connecting stuff, potential current carrying metal objects together. So they get rid of the potential difference between them and we minimize the risk of arcs and sparks. Ground is then taking the stuff that you've bonded together and connecting them to the earth. Grounded, connected to the earth. Ground fault, an unintentional connection between an ungrounded conductor and the metal parts. This electrically conductive path forms by accident in normally non-conductive scenarios like contacting metal enclosures, non-current carrying conductors like the ground, or metal equipment. Ground fault circuit interrupter, GFCI for short, not to be confused with AFCI that we spoke about earlier. A device intended to protect people by de-energizing the circuit when the current to ground exceeds the value established for a Class A device. Now remember the difference between this and an arc fault. An arc fault is trying to get rid of an arc, which generally is a small enough arc that could not create enough potential that it would make it back to the circuit breaker and trip the breaker, but it would create enough heat that it could start a fire. The GFCI is protecting people because it's checking the current going out and the current coming back to make sure that it's within a certain milliamp range, and if it isn't, it's going to take the device offline. According to UL 943, this happens at 6 milliamps or higher and will not trip at 4 milliamps or lower. The safe trip point is above 4 milliamps. So you're looking at 4 to 6 milliamps. So look at the picture we've got here, which is looking at your typical GFCI installation. Okay, so if you look at the power going out and the power coming back, not all of the power is in that circuit. Some of the power is leaving out through that hand that mysteriously is coming through the back of the slide there. So not all of it's actually making it back to the origination in the circuit. So because some of the power is lost, we're creating an imbalance on that circuit, and that imbalance will create a magnetic field and help trip that GFCI. More on the GFCI. GFCI protection does not protect against line to neutral shocks. So if you became part of that circuit by holding on to the hot and the neutral, and the current went straight through you, you could effectively become a low impedance path to go straight through with minimal work being done, so there may not be enough power loss through you to actually trip that GFCI. The failure rate of a GFCI averages around 12%. The outdoor locations, of course, are going to be higher. You've got more extreme conditions. Those are going to be at a failure rate around 20%. In some high lightning areas, you could be upwards around 50%. So keep in mind, while they're not foolproof, they're constantly getting better in the industry with these. Okay, here are some examples of GFCIs. Some of the things to remember. The failure rate's still close to 12%, even under the best conditions. If a lightning strike occurs, the GFCI most likely will fail while still allowing power into it. So it'll fail in the closed position. A ground wire isn't necessary for the function. So when people correlate a ground and the GFCI, those are two separate portions of the code and two different requirements. A ground is not necessarily required for a regular run-of-the-mill GFCI to work properly. It's looking at the difference between the exiting and returning current. And it won't protect against line to neutral shocks, and it's not meant to. Grounding electrode. A conducting object that's used to make a direct connection and a direct electrical connection to the earth. Some of the examples have been around for a long period of time, nothing really new here. Metal frame of the building, metal underground water pipe, concrete encased electrode, ground ring, grounding rod, and any other electrodes listed for this use. Grounding electrode conductor. A conductor used to connect the system grounded conductor or neutral or the equipment to the grounding electrode or the grounding electrode system. Okay, so your grounding electrode is, say, your ground rod. Your grounding electrode conductor is the wire that connects your ground rod to your box or the rest of your grounding system. Equipment grounding conductor. An intentional path that connects metal parts of the equipment, which normally are not carrying current, together, and the grounded conductor or the grounding electrode conductor. Okay, here's an example. Notice we're in a solar setting here. example. The equipment grounding conductor can be any one or a combination of the types listed in 250.118. It must provide an effective ground fault path. This part's new. 250.118 says the equipment grounding conductor run with or enclosing the circuit conductors shall be one or more or a combination of the following. Let's look at these 5 examples. Copper clad, copper or aluminum clad conductors, could be solid or stranded, insulated, covered, or bare, wire or bus bars of any shape. 2. Could be rigid metal conduit. 3. Could be intermediate metal conduit. 4. Could be electrical metallic tubing. And 5. Could be flexible metal conduit as long as it terminates in the listed fittings, has a 20 amp or less overcurrent, its length plus the liquid tight plus the flexible metallic tubing length combined is less than 6 feet, so we don't have much to work with there. And it's used where necessary to stop vibration or provide flexibility, but an equipment grounding conductor shall be necessary. Guest room. An accommodation that combines living, sleeping, sanitary, and storage within a quote-unquote compartment. Guest suite. Very similar to a guest room, but has 2 or more rooms in one compartment with or without doors between them. Hermetic refrigerant motor compressor. Combination of a compressor and a motor that are enclosed in the same housing. Has no external shaft or seals, and the motor is operating in the refrigerant. Okay, here's an example. In sight from also applies to within sight and within sight from. This is mentioned and no specific distance is given. The one piece of equipment has to be 50 feet or less invisible from the other piece of equipment. So notice our example here. And it's got to be in sight from. Doesn't say that it has to be on the same wall. Intersystem bonding termination. A device designed to connect intersystem bonding conductors for communications systems to the grounding electrode system. Kitchen. An area, again with the area, similar to bathroom, with a sink and permanent provisions for cooking. Means that your countertop microwave will not be included as a permanent provision for cooking unless you mount it. Labeled. Materials or equipment that have a label, symbol, or mark by an organization acceptable to the local AHJ. Okay, notice the UL listing here. Damp location. Locations that are protected from weather and not likely to be saturated with water, but obviously could. This includes areas that are only partially protected, like open but covered porches, canopies, or even soffits. Wet location. Locations that are likely to be saturated with water or unprotected from the weather. This also includes locations that are in direct contact with the earth, are in concrete slabs or masonry, or, of course, are underground. Oh boy, that would have to that would have to be probably one of the more dangerous pictures I think I've ever seen, where people are still living. Nonlinear load. A load in which the wave shape of the current doesn't follow the wave shape of the voltage. Nonlinear loads occur when the resistance is not a constant and changes during each sine wave of the applied voltage waveform, resulting in a series of positive and negative pulses. Traditional load. For reference as to what we should see, we've got a picture here. Examples of nonlinear loads. Fluorescent lights, electronic ballasts, dimmers, motors with adjustable speed drives, computers, data rooms. Overcurrent. Current that's in excess of the equipment rating caused from a ground fault, a short circuit, or an overload. Surge protective device. Three different types. Type 1, permanently connected and listed for the installation between the utility, transformer, and the service equipment. And notice on the lower left here, we've got that, it almost looks like a ring or a collar before that meter. That's your whole home surge protective device. Type 2, permanently connected surge protected device listed for the installation on the load side of the service disconnecting means. So just a different point of installation. Type 3, surge protective device listed for the installation on branch circuits. One final note on this, you want to make sure that you actually have a ground in the receptacle that these strips are plugged into, because their safety relies on that ground. In the event of a short circuit, it basically shunts to ground to trip that device. Article 200. Now we're getting out of the definitions and into Article 200, which deals with identifying the grounded conductors and terminals. 200.2 B. Continuity of the neutral conductor. Neutral conductor shall not depend on a connection to a metallic enclosure, raceway, or cable armor for its continuity. Here you've got the metal being used to connect the neutral to the neutral terminal through the metal box. Okay, that's not acceptable. .250.119, identifying an equipment grounding conductor. If the wire is 6 gauge or smaller, the equipment grounding conductor can be bare, green, or green with a yellow stripe. Article 210. Branch circuits. 210.3, branch circuit rating. The overcurrent device rating determines the branch circuit rating. 210.4D, grouping of multi-wire circuits. All conductors of a multi-wire branch circuit have to be grouped together in at least one location. This will be done using cable ties or something similar, usually at the point of origin. Here's your before and after. You'll notice on the left that we've got kind of a cluster. However, it's not labeled at all. But if you look on the right, somebody has gone back through, cleaned it up nicely, and labeled it. This should be done while marking the branch circuits in the box. It'll not be necessary if all the wires for the circuit are in a single raceway or if the circuits are tagged. The National Electric Code wants to have number tags. Now remember, we're talking about multi-wire circuits. We're not talking about just a normal circuit. 210.5, identifying branch circuits. 210.5C1B talks about how to identify them with your identifying means. If you have more than one voltage used on the system, the circuits have to be labeled at the panel or the board, and of course they've got to be labeled legibly. If you can't read it, then what good is it? 210.8, GFCI protection. 210.8, GFCI protection. GFCI devices required by 210.8A through D must be installed in readily accessible locations. You could venture back to the beginning of the program or break out your NEC to Article 100 and see what readily accessible locations are labeled as. Residentially speaking, this is designed to cover all 15 and 20 amp 125 volt receptacles in the following areas: bathrooms, dwelling unit garages, and accessory buildings. Now remember, there's nothing that says that you have to put power out to an accessory building like a shed in the backyard. But if you do, it's got to be GFCI protected. Receptacles installed outside, there are requirements for that. Crawl spaces, unfinished areas of a basement, kitchen countertops, within 6 feet of the outer edge of a sink. Okay, some of that is diminished as well once you get into bathrooms and things like that. A boathouse is another one. Within 6 feet of the outer edge of a bathtub or shower. And laundry areas. Continuing on with 210.8, B deals with other than dwelling units. Got to be in other than dwelling unit bathrooms, kitchens, rooftops, obviously for serviceable means, outdoor areas, within 6 feet of a sink, indoor wet locations, locker rooms with shower facilities, and garages, service bays, or any other similar area. 210.11, branch circuit requirements. 210.11a talks about the number of general lighting and general use receptacle circuits in a dwelling unit. Annex D gives the best examples that we've got. Looking at those examples, measuring the floor area of the structure along the outside wall, find the square footage. Here we've got 75 feet in one direction, 20 feet in the other direction. So we take 75 by 20 and we get 1,500 square feet. You take that number times 3 VA. So we've got 1,500 square feet times 3 VA equals what? 4,500. And there are other optional calculation methods for figuring out the general lighting and use outlets Those are in 220.82b1 and 220.83a1 for dwelling units. And more specifically, those optional methods deal with existing dwelling units. 220.12, general lighting loads by occupancy. Okay, notice where it says here for dwelling units, for our square feet for volt amps, that's where we're getting this, table 220.12. It tells you 3 VA per square foot. So just in case you were wondering where in the world we come up with the 3 VA per square foot. Annex D, again, going into D1A, figure the voltage that your circuits will have, normally 120 volts, and figure that in to find out how many circuits you can get out of it. So we figured 4,500 VA divided by 120 volts equals 38 amps. So your options here are to have two 20 amp circuits or three 15 amp circuits. There are quite a few other factors that go into this calculation. There's a derating factor over 3000 VA, like you'll see in table 220.42. Here's an example of some of the derating factors that we're talking about here. Derating factor for dwelling units calculated by multiplying the following percentages for the corresponding amounts of VA that has been calculated. Okay, for the first 3000 VA, we take it at 100%, so it'll be 3000 VA. You will then, at 3001 up to 120,000 VA, multiply by 35%. So it'll be the first 3000 plus whatever your second calculation here comes out to be. There are standard amounts of VA that are added to this calculation based on the circuit as well. They are the small appliance circuits, which are 1500 VA each, the laundry circuit, which is 1500 VA, the electric dryer, which is 5000 VA, or the nameplate rating. You take the largest one for that calculation. If you've got 4 or more fastened in place appliances, excluding dryers, ranges, space heating, and AC equipment, derated to 75% of the load. Here's your example of your calculation in example D1A for family dwelling units. And there are multiple examples that deal with different scenarios in your Annex D location. .11b. Make sure you space things out evenly, as it deals with evenly proportioned loads. You must make sure after your loads are calculated that they're evenly balanced from one branch circuit to another, and the wiring is calculated properly for the expected load. 210.11 talks about branch circuits that are going to be required. 210.11c deals specifically with dwelling units. C1, 2 or more 20 amp 120 volt small appliance circuits to cover the outlets in the kitchen, the dining room, the breakfast room, the pantry, and small dining areas. Now, just on a side note, when we did our D1 calculation just a second ago, and we were trying to decide whether we were going to use two 20 amp circuits or three 15 amp circuits, most commonly you're going to go with the 20 amp circuits because that's what most of the requirements revolve around. C2 deals with 20 amp, 120 volt circuits required for the laundry outlets. Those are required by 210.52F as well. You aren't allowed to add a receptacle or an outlet that's not in the laundry area to the laundry area. Just remember. So if you've got an adjoining wall with a bedroom, you're not allowed to sneak off the receptacles that are in the laundry room to bring it through the wall to the other side to that bedroom. Two 10.11 branch circuits required continued on with C, and again we're talking with C dealing with the laundry outlets in C2 and 210.52F. This receptacle is still going to be required. You got to remember your requirement specifically says in C2 that 120 amp 120 volt circuit is required for the laundry outlets required by 210.52. So the receptacle is still required even if the appliance being used will use another receptacle due to different power requirements. And the example would be a stackable washer dryer combo could use a 30 amp 240 volt receptacle and not use that receptacle at all. 210.11 still in the branch circuits required. We're moving on to C3, which deals with bathrooms, and one 20 amp 120 volt receptacle required for the bathroom receptacles. The outlets that aren't in the bathroom aren't allowed on the bathroom circuit, plain as day. You can supply all the outlets in a single bathroom if you'd like. Okay, on a single 120 volt 20 amp bathroom circuit. Okay, these can include the lights as well, as long as no single load more than 10 amps. And you can reference 210.23A1 and 2 for that particular requirement. And what you'll find there, 210.23A1 says cord and plug equipment not fastened in place is allowed to draw 80% of the load. And 210.23A2 says cord and plug equipment fastened in place is allowed to draw 50% of the load. Here's your arc fault breaker. 210.12 is going to get into AFCI protection, and when it comes to AFCI protection, we're in an area where not everything's going to be on the receptacle end of things. This is your new wave arc fault breaker, where both the line and neutral go into the breaker and the neutral connects back to the box on the neutral side. And primarily what you're looking for here is a characteristic of an arc fault. All 15 and 20 amp 120 volt branch circuits that supply outlets or devices in these locations require arc fault protection. What locations? Bedrooms, closets, dens, dining rooms, family rooms, hallways, kitchens, laundry areas, libraries, living rooms, parlors, rec rooms, sunrooms, and any other similar areas. So notice we got arc fault protection requirements actually in the kitchens and dining rooms in a lot of the same places that we have GFCI protection. There is a potential in which you'll have arc fault and GFCI protection required in overlapping scenarios. 210.12a does have some exceptions. Okay, one of the exceptions deals with fire alarms. Okay, and the short and sweet of it is, if the smoke alarm or the fire alarm is not controlled by the panel, then it doesn't qualify as a fire alarm circuit. So arc fault will be required. If they go to a panel, it will most likely not be required. Again, that's all subject to the authority having jurisdiction and any amendments that may be in your area. But listen to one of the exceptions. One of the exceptions references you over to 760.121, which is power sources for PLFA circuits. And it says in B, dealing with branch circuits, the branch circuit supplying the fire alarm circuit shall supply no other loads. The location of the branch circuit overcurrent protective device shall be permanently identified at the fire alarm control unit. The circuit disconnecting means shall have red identification, shall be accessible only to qualified personnel, and shall be identified as fire alarm circuit. The red identification shall not damage the overcurrent protective devices or obscure the manufacturer's markings. This branch circuit shall not be supplied through ground fault circuit interrupters or arc fault circuit interrupters. And another exception, another area that this exception actually references you to is 760.41b, which deals with non-power limited fire alarm circuits as well, and it says the same, almost identical thing, and that's 760.41b is your other reference point for this exception to the rule. So, like I said, short and sweet. If it goes to a panel, doesn't qualify, or if it goes to a panel, it won't require arc fault or GFCI. But if it doesn't go to a panel, it's probably not going to qualify as a fire alarm circuit either, and it's going to be required to have arc fault protection. 210.12b talks about branch circuit extensions or modifications, more particularly with dwelling units. In areas where branch circuits are modified or replaced or extended, the circuit must be protected by an AFCI circuit breaker or an AFCI receptacle at the first outlet. Now remember, there will be a requirement also in the branch circuit area that says that this circuit's going to have to be grounded at least to that first receptacle. Doesn't have anything to do with the way that the arc fault circuit interrupter works. It has to do with creating an effective ground fault path that goes all the way back to the panel. The exception, if the extension is less than 6 feet when no devices or outlets are added. 210.17 Electric vehicles. An outlet that has been installed for the purpose of charging electric vehicles shall be on a dedicated branch circuit with no other outlets. 210.18 Guest rooms or suites. Guest rooms or suites have to be wired according to the branch circuit requirements for dwelling units. Okay, so as you might guess, staying in hotels, when you look around, there would be a distinct difference between whether or not you're considered a suite or a dwelling unit or a guest room as far as how the wiring is done. For the most part, obviously, you're going to have circuit protection and all that kind of stuff be fairly close in all those applications where habitation is going to take place. However, there are some fairly small nuances between those that would definitely make a big difference in a multi-story hotel. 210.23 Permissible loads. 210.23 says in no case shall the load exceed the branch circuit amp rating. 210.23 Goes on in section A that says 15 and 20 amp circuits can supply lights and utilization equipment. A1 says it can go on and include cord and plug as long as they're not fastened in place. It can only pull up to 80% of the circuit amp rating if it's cord and plug not fastened in place. A2 talks about utilization in equipment that is fastened in place, and it can only pull up to 50% of the circuit amp rating. Remember, both of these are indicating that there's something else on that circuit as well. So the 50% and 80% is, if in addition to whatever's pulling that amp draw on the system, you also have potentially a light or something else plugged into that circuit as well. A2C says that 40 and 50 amp circuits can contain cooking appliances that are fastened in place. Okay, so that's a bit of an anomaly. And A2C also says that you can have 50 amp circuits that can supply non-lighting load outlets only as well. So it just breaks the mold of the 15 and 20 amp circuit requirements that we've got here. Goes into a few nuances. So as we head into part 3 that deals with required outlets, just to give you folks that are keeping track a little update, where if you're following along in a code book, you should be in a normal traditional National Electric code book. You should be on page 60. It's not the same in the handbook, but if you're following along in a traditional, it'll be the same. We're going into part 3 dealing with required outlets. 210.50 deals with your general requirements. Requirements for installing outlets shall be done in accordance with 210.52 through 210.64. Small section, lots of stuff in it. 210.50A deals with cord and pendants. Don't overlook the fact that flexible cord and pendant receptacles are still receptacles. They are still allowed to achieve the requirements that may be required, whether residential or commercial, in areas that do require the receptacles. 250.C appliance receptacles. The concept here is very simple. If the receptacle is intended for a specific appliance, like laundry equipment, the example given here, then that receptacle's got to be within 6 feet of the intended appliance. It seems like that's an awful long ways away because most of the cords, unless you're going to change out the cords or buy a longer whip or something, are not going to extend 6 feet. But nonetheless, that is the rule. 210.52, dwelling unit receptacle outlets. 210.52 covers 125 volt, 15 and 20 amp receptacle outlets. The outlets are in addition to those that are part of the luminaire appliance, controlled by a wall switch, like you see in 210.70A1, exception 1, switched receptacles, or those in cabinets or cupboards, so potentially one that would be covered up, such as one that you would plug a hanging microwave into, are those located 5.5 feet off the floor. Remember, it's in addition to those receptacles. 210.52 deals with the switching of receptacles, and I wanted to take just a second and just point out the fact your wall placing on your receptacle requirements requires your basic, in a dwelling unit, 6 foot, 12 foot rule. So you should be able to go to any point along the wall, and within 6 feet of that point, one direction or the other, you can reach a receptacle. That requirement does not say that you have to use a duplex receptacle like the one pictured here. What the requirement says is you have to have a receptacle. The advantage that you get with a duplex receptacle is in the event that you need to achieve a lighting requirement as well as a wall spacing receptacle requirement, you could meet both with one duplex receptacle by separating the top and bottom receptacle. And then you could achieve your lighting requirements at 21070A1 and then the receptacle requirements at 21052A1. 21052, getting into the heart of it. A, general requirements for a dwelling unit. A1 deals with spacing. The requirement for a receptacle to be installed in every kitchen, family room, dining room, living room, bedroom, etc. says that no point along the floor line of any wall space should be farther than 6 feet from a receptacle. That's why we slang term call it the 6 foot, 12 foot rule. The rule says no further than 6 feet in one direction or the other from a receptacle or to get to a receptacle, when in reality, if you went dead smack in the middle of two receptacles that were right on the money, 6 feet both directions, it would be 12 feet between the two. 21052A2 deals with wall space. Wall space in the dwelling units shall include 1. Any space that's 2 feet or more and unbroken along the floor line by doors or similar openings, fireplaces, and fixed cabinets. This includes spaces around corners. You can't go catty corner for your spacing requirement. 2. Fixed panels on interior walls. Large glass panels like those found in the sliding doors that don't actually slide. Now, when you've got sliding doors, generally you've got one panel that slides and one panel that doesn't. 3. Fixed room dividers such as railings. Now, one thing that throws a wrench and oftentimes a homeowner into a tailspin is the requirement at 21052A23, fixed room dividers such as railings, because this also can refer to banisters at the top of a long stairway or along a lofted walkway in a vaulted room. You've got banisters along those edges so that somebody can overlook, say, the living room from a vaulted area. That could be considered wall space, and you would have to have a receptacle in that area. Now, obviously, if you've got the nice spindled banister along that walkway, you're not going to put the receptacle in that banister. What you're going to do is you're going to probably put it in the floor. And they do make nice alternatives for the floor mounted receptacles. So, here is an example of your requirement. This is the 6 foot, 12 foot rule. Any point on the wall should be no further than 6 feet from the nearest receptacle. So if you're in the middle, dead smack in the middle between two receptacles, it could be 12 feet total. So notice, even the small little 2 foot space in the middle center requires its own receptacle because of the requirement. Two 21052A3 is a part I wanted to point out. I just talked about that. If you've got a vaulted area or a walkway that has a banister and no wall on the other side, say you've got a banister on both sides, your receptacle is still something that you're going to have in those areas. So you have to keep that in mind, and you may have to put a floor receptacle in there in order to comply. Floor receptacles can be counted as your required receptacles, but only if they're installed within 18 inches of the wall. Hey, here's another example. Imagine having this beautiful hardwood and still having to put a floor receptacle in there. Again, they make good alternatives for it, so you'll have to plan ahead and make sure that the homeowner is aware of this requirement. 21052A4, countertop receptacles. Dwelling unit receptacles versus countertop receptacles is a little bit different. Countertop receptacles are installed according to 21052C, and countertop requirements cannot be used to achieve the requirements of the general dwelling units in 21052A. Now, what does that mean? In looking at this picture, what this means is you're not allowed to use your receptacle on that countertop to achieve your receptacle requirements along the wall spacing there on the floor. So you may end up with a couple receptacles that are extremely close to each other. 21052, dealing with dwelling unit receptacle outlet requirements. This is Section B, small appliance circuits. 21052B1, dealing with small appliance circuits, says the 20 amp 120 volt small appliance circuits covered in 21011C1 and the requirements found in 21052A and C are meant to extend to kitchens, breakfast rooms, pantries, and dining rooms. Okay, now remember, we had the option clear back when we were talking about the annex and the calculations for a dwelling unit to split. After we calculated the VA that we needed and divided by 120 volts, we were allowed to do two 20 amp receptacles or three 15 amp receptacle circuits in those areas. And although three circuits sounded better, most of these requirements are all 20 amp circuit requirements, like the small appliance circuit requirement. 21052B1, exception number 2. Refrigerators are allowed to be on a dedicated branch circuit as long as it's rated 15 amps or more. So you can have it on its own circuit. It doesn't have to be on the small appliance circuit. The one anomaly is you're not allowed to extend that refrigerator plug, refrigerator's flexible cord up over the top of the countertop to a plug-in that's up there. It would have to be something that's not in a fixed position like that, above the countertop. 21052B3, kitchen receptacle requirements. Here we have a nice wide open kitchen. You have to have at least two small appliance circuits in the kitchen. They can also supply the pantry, breakfast room, dining room, all of the other requirements in 21052B1, but it cannot supply another kitchen. C1, talking about wall countertop spacing. Each countertop space shall have a receptacle. At no point on the wall space should the receptacle be more than 24 inches away in one direction or the other horizontally from that area. So what are we talking about there? Well, in a dwelling unit living room, it was a 6-foot, 12-foot rule. Here we're talking a 2-foot, 4-foot rule. So at no point should you be able to touch a countertop space and be more than 2 feet in one direction or another from a receptacle. Okay, so if you were smack dab in the middle, you effectively could be 4 feet between the receptacles itself. Okay, there are exceptions. Normally, they're not going to be required behind a sink or a range. In addition, they're not supposed to be more than 20 inches off the top of the countertop, and you'll find this at 21052C5. Exemptions. We talked about this just a second ago. Normally, you're not going to find it's required around the back of a sink. Okay? However, if there's more than 18 inches behind that sink, that requirement will be there. The illustration in the NEC clearly shows if you've got less than 12 inches behind the sink or the range, less than 18 inches if it's a corner, then no receptacle is required. If you got more than 18 inches, you're certainly going to have that requirement extend behind that corner there on the picture on the right. This is the actual picture out of the NEC that is given for your example. The illustration fairly clearly shows that if you've got less than 12 inches behind a sink or range, 18 if it's in a corner, then you don't have to have a receptacle. 21052C2, island countertop spaces. Each island space has to have at least one receptacle. The requirement is one receptacle. Island dimensions necessary to meet this requirement are a minimum 24 inches long and 24 inches wide. That's your minimum requirement. If that was all one island countertop, nothing on there, the requirement's one receptacle. Some municipalities have that extended out to mean that you have to have two receptacles, but the requirement in the NEC is one. 21052C3, peninsular countertop spaces, are very similar. Each peninsular space has to have at least one receptacle, same as the island. The dimensions are exactly the same, but you have to remember that the peninsular starts at the connecting edge of the counter, not at the wall. So your minimum diameter, or your minimum length from the countertop to the end of the peninsular is 24 inches long, and the minimum width 24 inches wide to that connecting edge. Now it is possible that in that area you may not have any place to put a receptacle. Maybe not on the end, maybe not in the countertop. There are scenarios where that comes up. You will notice almost dead center here that you've got a flip down door with a receptacle inside of that space. And that, believe it or not, is not just something that somebody came up with on a whim. That's a designed product for that purpose. It's for your upper end custom style kitchens that don't want the visibility of that additional receptacle because they don't use it all the time. So they only have it exposed while it's being used. Some municipalities will have some different requirements there. So for instance, one municipality will not allow you to have that kind of installation unless there's a way to only activate that plug when the lid is slid back into a position that the lid cannot be closed on the plug that goes into it. We have all kinds of new devices that are allowing us to be a little bit more upscale, make things look a little bit nicer, and still comply with code. These are some in countertop style receptacles, and these are UL listed and approved for the wet purpose. 21052C4, separate countertop spaces. Traditional kitchens oftentimes are going to have appliances that are spaced out so that they make sense to actually use. They're not going to be all grouped together. They're not going to be installed to make it so it's easier to comply with code. They're going to be spaced so that they make sense. Usually, this will create little separations in the countertop, oftentimes, say, between the range and the stove, maybe a little, like almost a little part of countertop that just kind of stands out by itself. These are going to have receptacles. 21052C4 deals with these separate countertop spaces. If you have countertops that have areas separated by a sink, range, refrigerator, or another similar appliance, the space has to comply with 21052C1. Okay, so you'll notice here if you've got a space that's 12 inches or wider, like the far right there, between that range and maybe there's a refrigerator on the right hand side of that arrow? Well, it's broken up the countertop into a 12-inch space. That 12-inch space will now have to have its own countertop receptacle, and then the receptacle requirements on the left-hand side of that range is going to start from there, and have to have another receptacle within 12 or 2 feet from that range. And again, here's another great example. If you have countertops that have areas separated by a sink, range, refrigerator, or other similar appliance, it has to comply with 21052C1. Again, if there's less than 12 inches behind the sink, you don't have to have a receptacle. The requirement says if there's more than 12 inches behind that sink, you will have to have a receptacle behind there. More with this 21052C4. Peninsulas and islands are no different. If you have a peninsular space or an island space, and you've got more than 12 inches separating the closest edge of that sink to the other edge of or the larger edge of the countertop of the peninsular or island, like you see in the left-hand example here with a sink, more than 12 inches, it's not considered a broken space. So the requirement is only one receptacle in that entire space. It doesn't matter if that island is 20 feet long. It's still going to be considered one space. If you have the space separated by a range or some other appliance that creates a space that is less than 12 inches from the back of it to the edge of the countertop, such as the example in the right hand side here, then that will be considered two separate spaces and will require one receptacle in each of those spaces. We're still referring to countertops here, but we're talking about 21052C5 with outlet locations. Receptacles shall be located on, above, but no more than 20 inches above, in, as long as listed for it, or below, but not more than 12 inches, and only if the counter overhangs less than 6 inches for the countertop. Those are your requirements. There are exceptions. Okay, you've got an exception here. Exception 2, if the island or peninsula is completely flat with no backsplashes or dividers and no means to mount a receptacle 20 inches above the countertop, like cabinets, then there is no receptacle requirement. That is a valuable place to start when you're looking for ways to comply with the code in the peninsular or the island compliance area, because there are absolutely some areas where you're not going to be able to install that. Now, if you're thinking about it, some guys are really wrapping their heads around that, thinking, now how would there ever be a scenario where I absolutely could not put a receptacle in there? Well, what if you didn't have any overhang at all on that peninsular or island, and there was drawers out both sides that slid right up to the edge of the wood, so that you could not mount a receptacle in there because it would it would be slid into by the doors and such. There are some scenarios that this will really help you out. It's not there as a get out of jail free card, but it's there to aid you in compliance in areas that you absolutely could not follow the traditional rules. 21052C5 deals with receptacle outlet locations and appliance garages. If you have an appliance garage, it can't be used to meet your spacing requirements for the countertop receptacles. However, your receptacles for the countertop small appliance circuit can extend right on inside of the appliance garage. So you can have it in there, but it can't be used to meet your receptacle requirements. So your 2-foot rule would start on either side of that appliance garage and head out along the wall space, and you'd have to have a receptacle within 2 feet there. 21052D, bathroom requirements. And we've talked about earlier that there are receptacle requirements and GFCI requirements and such around sinks. And we talked about sinks just in general having a 6 foot rule. If you're around a sink, you're going to have GFCI protection within 6 feet around that in a radial spherical style around. But in a bathroom, your receptacle requirements say you must have a receptacle. 15-20 amp, of course, is a requirement here, as most of them are, within 3 feet of the outside edge of each basin or sink. So we're talking a 3 foot radius. Okay, and that's a perimeter, all directions, any of these areas. Could be on the outer side of the cabinet, could be in front of the cabinet, but new requirements allow no further than 12 inches below the front edge of the sink. And it can be in the sink or in between the sinks on the countertop area. 21052E deals with outdoor requirements. Receptacles need to be in these areas outdoors in these locations in a 1 and 2 family dwelling. One receptacle in the front and back of the dwelling at grade level. It shall be readily accessible and no more than 6.5 feet above grade. 2. Multifamily dwellings. You only have to have your receptacle outside in the front and back at a multifamily dwelling on the dwelling units that are at grade level. And that's it. 3. On balconies, decks, and porches. Only required when attached to the dwelling and accessible from inside. So right outside your back sliding door, for instance. You shall have a receptacle that's no more than 6.5 feet above and accessible from the balcony, deck, or porch walking surface. 21052F gets into laundry areas. In dwelling units, you have to have at least one receptacle, 15 amp or 20 amp, 120 volt, in the designated area where the laundry equipment is intended to be installed, even if it's not being used. And one example that was given recently is, what if I've got a new construction home and the person that's paid for the home, that's buying the home, going to move into the home, has a stackable washer and dryer. So they would never use a 120 volt 1520 amp circuit. They would only use the elevated, probably 30 amp 230 volt circuit. So what would you do then? The requirement's there even if it's not being used. And notice it talks about laundry area, not laundry room. Exception 1. It shall not be required in a single dwelling of a multifamily dwelling unit that has laundry facilities provided for use by all building occupants. Okay, so if you've got one dwelling of a multifamily dwelling unit that has laundry facilities already for everybody, you don't have to abide by this rule. You don't have to have the laundry circuit inside of the single dwelling in this instance. 21052G, basements, garages, and accessory buildings. In a single-family dwelling, at least one receptacle outlet shall be in these areas required by 21052G1 through 3. These, of course, are in addition to any that might be required for specific reasons dealing with potentially specific equipment. Garages. If a detached or attached garage, notice the key word there, if, has electrical power supplied, you have to have one receptacle in each car space, minimally. So So as you can see here in this garage, we don't have a requirement. We've got one receptacle dead center in the middle and no receptacle in each space. Accessory buildings, which is 21052G2. Accessory buildings have to have at least one outlet receptacle in each accessory building that has electrical power supplied. Nothing says you have to supply power to this fancy little shed with an open and with an inward door and an outward door on the other side. A little bit more fancy than what I've got, but nothing says you have to supply power to this. But if you do, one, it's going to have to be GFCI protected, and two, it's going to have at least one outlet receptacle. Basements. You have to have a receptacle outlet in each unfinished area of the basement. In speaking with several code officials and looking at this picture, this is all considered one unfinished area until they start extending the wall out and separating the space a little bit more. So in this area, your requirement is one. Remember, if you have a finished basement, the outlet requirements of 21052 are enforceable depending on how the basement's finished. If you've got a secondary living space or kitchen or bathroom, those requirements may all revert back to 21052 A through C, which deal with your countertop space and your wall spacing requirements and all of that. Two 21052H, hallways. If a hallway is at least 10 feet long, the requirement says you have to have one receptacle, at least one receptacle. If the measurement is made along the center line without passing through the doorway, that is. Okay, so your measurement in the hallway is 10 feet as long as you're not passing through the doorway. So if you have a 40-foot bath or a 40-foot hallway, the requirement doesn't say you have to have at least 4 receptacles, one every 10 feet. The requirement says if it's at least 10 feet, you have to have at least one receptacle. 21060, guest rooms, suites, and dorms. 21060A, general requirements. In these areas usually found in hotels and sleeping rooms and dorms, the minimal requirements are those of 21052A and D. Okay, so your 21052A and D are still at play here. If there are also permanent provisions for cooking, they'll have to comply with all of 210.52. So the difference is whether or not we're talking permanent provisions for cooking. Oftentimes you're going to see a countertop microwave be all that you have. But if that microwave leaves the countertop and is now mounted up above the counter, or you have a cooktop or something like that, we could have a permanent provision for cooking and become the same as a dwelling unit as far as requirements go. 21060B, receptacle placement. Hey, this is kind of interesting. The quantity of receptacles must be the same as the requirements in a normal dwelling unit, but the spacing requirements may be altered to fit the placement of the furniture. So that is different. And now we go back to the old mentality of usable wall space, which hasn't really been in the code book since the 50s. If you have a couch there, by nowadays standards, I wouldn't consider that usable wall space, but it doesn't exempt you in a normal house from using that space for a receptacle, because you still have to meet your receptacle requirements. Here we're saying when we get into guest rooms and suites and dorms that the requirements can be altered to fit the placement of the furniture, and usually that's going to be because you have such a small living area. If the receptacle's behind the bed, this is another example given in the code book. It has to be in a way that prevents the attachment plug from touching the bed, or it must be guarded. At least two receptacles shall be readily accessible. And you also have all the same requirements for GFCI that you'll find in later chapters. Article 300, General Requirements for Wiring Methods. 300.1 deals with wiring installations in Part A and integral parts of the equipment in Part B. Okay, 300.1a, this article covers all general wiring methods for all installations unless modified in other chapters. Could be modified in chapters 5, 6, and 7, or even in 8. And B, integral parts of the equipment. This article does not apply to conductors that are integral parts of accepted or listed equipment. These are conductors that are placed there by the manufacturer during the manufacturing process of the equipment. 300.2 Limitations. 300.2a Voltages. Wiring methods in Chapter 3 are designed for voltages that are up to but not higher than 1000 volts unless specifically permitted or allowed elsewhere in the code. 300.2b Temperatures. Temperature limitations of the conductors are in accordance with 310.15a3. Now, 310.15a3 is called temperature limitations of conductors. It references tables that you look up with the allowable ampacities and temp limitations and their derating tables for elevated temperatures, similar to what you would use for 310.15b2a and b. 300.3 Conductors. 300.3a Single conductors. Single conductors is specified in 310.104a, have to be installed within a recognized wiring method. So in looking at what we've got here, we got some knob and tube. And while this may be an existing building, now look at the size of the wood, true sizes of wood. You don't see that anymore. And it may actually still be used. It's there under the existing building exemption. It's not posing a danger or a threat, and it hasn't been upgraded because the building probably hasn't been modified to make it be upgraded. However, you wouldn't see this put back in a new building because it's no longer a recognized wiring method. They want all of the conductors for a circuit to be run together within the same wiring method. Conductors. In 300.3b, same circuit conductors. There are some exemptions to this rule, but generally, all conductors of the same circuit, including grounding and bonding conductors, shall be grouped in the same wiring method. Some of the exceptions are found in 300.3b1 through 4. .4 Protection against physical damage. If the wires are going to be subject to damage, obviously you should be protecting them. Okay, some of the ways that you would protect them. A strike plate. Strike plates are neat, they're handy, and if you try to screw into them or nail into them, they're going to definitely let you know it ain't going to go in there. Okay, on wood, if it's been notched or bored and the hole leaves less than 1/4 inch in front of the stud, you have to use a strike plate. It also applies if it's likely that a nail or a screw can penetrate it. Okay, that's 300.4b2. You could use a bushing. If you've got non-metallic cable going through steel framing, now we use all kinds of steel studs now. It's got to be protected with a bushing. Support. If cables or raceways are supported to framing or furring strips, it has to be supported. Okay, there is really no specific method as to the intervals of the support, so that's going to be up to your AHJ, possibly depending on the scenario, could be up to more than one authority there. It can't be closer to the front edge of the wall than a 1/4 inch, or it has to be protected from nails and screws. If it's above a drop ceiling, the non-metallic cable still has to be supported. It's not allowed to be laid on those ceiling tiles according to its applicable article in 300.4C. 300.4G, insulated fittings. If the wire is larger than 4 gauge, the wiring method that goes into the box, cabinet, or enclosure has to terminate with an insulated fitting. Okay, some of these are just little nuances that are in the code that are there for specific purposes, usually pertaining to heat buildup, fire, or general contact with the wire through the sheathing if it gets rubbed or bare. 300.6 deals with corrosion and protection against it. 300.6A3, concrete or direct concrete burial with the earth. Ferrous metal raceways or boxes can be in contact with or even in concrete as long as it's either listed for the application, okay, that should go without saying, or if it's not listed, protected against corrosion. Some of the examples would be EMT, galvanized EMT. It requires corrosion protection. Rigid metal conduit, though, if it's galvanized, does not normally require anything additional as far as protection goes. 300.7, raceways exposed to different temperatures. 300.7b, expansion fittings. Raceways shall be permitted with expansion fittings if thermal expansion is a possibility. Hey, if you've got long runs and high temperature swings, usually we're talking 100-degree temperature swing. Hey, for instance, in the Midwest, it is completely likely that you could get down below zero in the wintertime, yet also above 100 degrees in the summertime. So you've got that 100-degree temperature swing there. Metal, plastic, and everything in between expands and contracts with that high amount of temperature change. So having expansion fittings is very valuable in this scenario. 352.44 deals with PVC expansion, and of course it's given as the next example. Okay, right here. If you've got a temperature change of 100 degrees, we're talking bottom center of this chart, then the length of change for this PVC conduit is how far? 4 inches for every 100 feet. So if you got a temperature swing of 100 degrees, like most places in the Midwest, then you very easily could have a 4-inch gain or lag in that PVC conduit. 300.10, electrical continuity of metal raceways and enclosures. If you have to form an effective ground fault path between all raceways, cables, and enclosures to make sure the circuit's overcurrent device will work in the event of a fault, then of course you're going to have to consult the NEC to do so. An effective ground fault path is one that's installed on purpose, as we discussed earlier, to provide electrical continuity from the equipment or the appliance all the way back to the panel. Hey, this is different from a regular, just run-of-the-mill ground fault path. A ground fault path is generally going to be any method that can take a electrical current to earth, to the ground. Now here we're talking about an effective ground fault path, which is one that's put there by you on purpose to take that electrical continuity back to the panel so that we can aid in the tripping of the breaker, popping of the fuse, whatever the case may be. 300.12, Mechanical continuity. Raceways shall be mechanically continuous between the fittings and the enclosure, box, or panel. Why is that? Well, if they're not electrically continuous and you've got a little gap in there and you start to run electrical current on the outside of that fitting or the raceway, then knuckleheaded me comes along and touches one side and then the other side or bumps into it, I could bridge the gap there and that current could run through me to the other side where there's also metal conduit. So I could become part of that circuit. 300.13 deals with conductors and mechanical and electrical continuity. 300.13a, general. No splices or taps inside of the conduit. Should go without saying. You can't service them. You can't see when there's an issue either. 300.14, the length of free conductors at outlets, junctions, and switch points. Well, we're always asking, okay, how much conductors, how much of the free conductor are we supposed to be pulling when we're wiring up our switches or our receptacles or any of those things? It gives us the answer right here in 300.14. You have to have at least 6 inches from the point it leaves the conductor, or I'm sorry, from the point it leaves the conduit or the connector at the box. 300.20, induced current in ferrous metal enclosures or raceways. Alternating current circuits in order to minimize the possibility of induction. Remember, induction is the creation of current using the magnetic field of the wires. Okay, we want to minimize current on the actual metal enclosures, of course, especially if they're ferrous, which is magnetic. Minimizing the possibility of induction on box and metal conduit, etc., you must group all the conductors together. Grouping them all together makes them have opposing magnetic fields. It doesn't cancel each other out like some people say in slang. What it does is it cancels the effects so that you don't have, or at least you minimize, the risk of those magnetic fields on that ferrous metal. 300.22b, wiring in ductwork. Ducts that carry heating, cooling, ventilation are only allowed to have wiring methods in or through them if it's necessary to make the equipment operate properly, or accessory or equipment. So sometimes there's accessories that are mounted inside the ductwork that could necessitate wiring, or if the product is listed for the installation and the AHJ allows the installation. 300.22c is an exception. It allows passing through joists or studs that are used for environmental air. Now, oftentimes we'll see thermal pan or some kind of metal that's placed on the studs or the joists that allows us to use return air for part of the ductwork in the mechanical system. 300.22c allows you to have wires that will pass through those areas. One thing that's kind of an anomaly, maybe a little bit of a sidebar, if you're utilizing combustion air drawn through the attic from the soffits into the mechanical room, some inspectors will view that attic as now being part of the ducted system and will not be happy with you in that instance in using the attic with open wiring, can lights, things like that, and will possibly make you meet even stricter requirements than you normally would for your wiring methods in that attic. So think twice about how you bring combustion air into a mechanical room. My suggestion would be to mechanically duct it. 310.15, ampacities. Okay, here is wires up to 2,000 volts. Okay, your different ampacity ratings. Now notice this is table 310.15 B16, probably one of the more common tables that you'll use for wire sizing in the code book. Obviously, there's no derating or anything like that on this particular chart, but you've got your ampacities on both sides, and that's to make it convenient so that you can see copper on the one side easily without tracing it around, and aluminum or copper clad on the other side. Three ten fifteen b sizing tables. You'll find sizing tables at 310 15 B16 through 19. And some of the factors that you'll be considering here are ambient temperature, overcurrent protection, compliance with product listings, and any other safety related influences. Again, this is just an example of table 31015B16 that would be used for sizing. But of course, there's 31015B16, 17, 18, and 19, which fit, of course, different applications. Chapter 4. Chapter 4 is titled Equipment for General Use. Article 400, Flexible Cords and Flexible Cables. 400.1, the scope, the overview of this very chapter, says that it covers general requirements for flexible cords and cables in construction and otherwise. Okay, that's a pretty broad statement for and otherwise. The suitability at 400.3. Cords have to be suitable for the environment they're in. This includes the fact that they may possibly have to be guarded, supported, watertight, or corrosion resistant. 400.5. Ampacity of flexible cords and flexible cables. Tables 400.5A1 and 400.5A2 have the conductor ampacity in cords and cables with up to 3 current carrying conductors at ambient temperatures of up to 86 degrees Fahrenheit. If the temperatures are supposed to get above 86 degrees Fahrenheit, you're going to need to derate the acceptable ampacities using table 400.5A3. 400.6a, markings. Remember, if a cord's listed for an unusual location, it'll say so in a factory-made marking on the cord. Some of the examples: corrosive locations, wet, sunlight or UV resistant, or high temperature, etc. 400.7 gives us our permitted uses for these flexible cords and cables. 400.7a, pendants, wiring of luminaires or self-contained lighting apparatuses. 3. Portable lamps, signs, or appliances. 4. Connection of interchangeable equipment. And 5. To simply prohibit noise transmission. Convenience. Okay, here are some examples that we've used in the past. Okay, these are used to promote not only the ease of moving these units around, but also it cuts down on vibration and therefore adds safety, as well as it simply cuts down on the attenuation or the noise that would be created. 400.7 B, attachment plugs. When cords are used in accordance with 400.7a, 3, 6, and 8, it shall be energized from an outlet or the cord connector body and have an attachment plug. There are often times when I'll have a guy that'll ask me, is it possible that I could put in a garage door opener and cut off the plug end and wire it directly? Well, certainly anything is possible, but that's definitely frowned upon because uh, your Article 400 specifically addresses scenarios like that. If it's a flexible cord connector that's supposed to have a plug, it's got to have a plug on the end. Period. 400.8. Uses not permitted. Flexible cords shall not be used this way. Very straightforward. As a sub for fixed wiring of a structure. So it's not supposed to be permanently wired. You're not supposed to run it through holes in walls, ceilings, floors, including drop ceilings. Shouldn't be run through windows or attached to the structure at all unless it's compliant with 368.56, which says that it's going to deal with cords and cables as its primary goal. Concealed by walls, floors, and ceilings. Not supposed to be in raceways or where it's possible that it could be subject to damage. Okay, these are some examples. This is in a drop ceiling. It's just laying on top of the ceiling tile. Somebody lifts that tile off, they're going to take one in the noodle from that little box there. Hey, here we've got one coming out through a window. One guy looked at that and said, is that CSST or flexible gas pipe? No, that's a big old drop cord. 400.83 prohibits this. 400.82 prohibits this. This was actually done at a dear relative of mine's house to wire in their ceiling fan by a local contractor. 400.9 splicing. Flexible cords should be used only in continuous, unspliced, or tapped lengths and in accordance with 400.7a. 14 gauge and larger cord repair shall be permitted. Okay, so for those of you guys that thought that you just had to cut your cords up and toss them away because they're damaged, listen to this. 14 gauge and larger cord repair shall be permitted as long as the installation, outer qualities, and usage characteristics of the original cord are maintained. Now, a lot of that's going to be up to whether or not the inspector feels that it has been maintained. And then also, are you using listed devices to reattach or to repair your cord with? Okay, here's some examples of a cord repair. Okay, we're putting a new end on here. 400.10, pull at joints and terminals. Common sense is going to tell you that you want to make sure that you've got something meant to keep the stress and strain off the flexible cords. Okay, this is going to keep the tension off the cord, but it's also going to keep the tension off of the equipment that is connected to or the parts as well. Okay, here's some examples of some items that are used to cut down on tension. Probably one of the more common ones right here. 406.4, general installation of receptacles. These requirements shall be done in accordance with Part 3 of Article 210, which we addressed earlier in the program. 406.4a, grounding type. Except for what you find in 406d, 15, 20 amp branch circuit receptacles shall be the grounding type. 406.4b, to be grounded. Okay, that's the actual title of this section. Receptacles as well as cord connectors that have equipment grounding conductor contacts must be connected to an equipment grounding conductor. Very, very explicit in its explanation. Okay, still in 406.4, C, methods of grounding. The equipment grounding conductor of the receptacle and cord connectors shall be connected to the equipment grounding conductor of the circuit that is supplying the receptacle or cord connector. The branch circuit wiring method shall provide an equipment grounding conductor for the receptacle. Very, very important. See what it says there. The branch circuit wiring method shall provide an equipment grounding conductor for the receptacle. Very, very important to remember that in some certain situations. (406.4D) replacements. Replacements must be done in accordance with 406.4D 1 through 6. Arc fault circuit interrupters and ground fault circuit interrupters shall be installed in readily accessible locations. Okay, we're going to look at 1 through 6 here. Grounding type. If there's a grounding means in the receptacle enclosure already, you have to use a grounded receptacle in the replacement. D1 has to be in accordance with 250.130C. (406.4D2) non-grounding type. Where there is currently no grounding conductor in the receptacle enclosure, you must comply with A. Non-grounding receptacles can be replaced with another non-grounded receptacle. Remember, we want to label it. B. Non-grounding receptacles can be replaced with a GFCI receptacle as long as it's marked, words given here in the NEC, no equipment ground. And C. Non-grounding receptacles can be replaced with a grounding type receptacle that is supplied through a GFCI and marked no equipment ground. (406.4D) 3. Ground fault circuit interrupters shall be provided where required elsewhere in this code. Exception: where the enclosure will not physically fit a new GFCI receptacle, you can put in a new version of the existing receptacle where GFCI is already provided, and the receptacle is marked both GFCI protected and no equipment ground. Okay, remember, key words here, where GFCI is already protected on the circuit. 406.4D4. Arc fault circuit interrupters. Where AFCI is required, the receptacle shall be one of the following: a listed AFCI receptacle, a receptacle already protected by a listed AFCI receptacle on that circuit, or a receptacle protected by an AFCI breaker. Remember, the replacement of the receptacle has to either be a listed receptacle AFCI, a receptacle that's already protected by the AFCI receptacle that's on that circuit, or it's got to be on a circuit that's protected by an AFCI breaker. 406D4.1 became effective 1/1/2014 according to the National Electric Code on page 282, in case you're interested. Five deals with tamper-resistant receptacles. They must be provided where required by other sections of the code. 406.12 is one of those areas. Tamper-resistant receptacles. Tamper-resistant receptacles shall be installed in accordance with 406.12A through C, and that's a new section in the code book. 406.12, tamper resistant receptacles. Again, 406.12 tamper resistant receptacles shall be installed in accordance with 406.12a through C, and my example here is just A, in dwelling units. In all areas specified in 21052 that have, so remember, this is all of your requirements, your countertop requirements, your dwelling unit requirements in general, living room, everything. All areas specified in 21052 that have 15 amp and 20 amp 125 volt receptacles, you shall use listed tamper resistant receptacles. Period. Welcome to Understanding the NEC, Part 2. In Understanding the NEC Part 2, we'll discuss chapters 5 through 7, special circumstances, special occupancies, communications. We'll talk about a little bit in chapter 8 as well. So we'll cover quite a gamut here too. It should last around 2 hours. Now, most states require follow-up questions after these online classes. So what will happen is you will take this as a required part of your online training. Probably every 15 or 20 minutes or so, random generated questions will pop up, and just make sure that you're sitting in front of the computer to answer those questions. You have a very short period of time to answer that, and that's for feedback purposes. The feedback purposes are there to make sure that somebody's actually there paying attention to the course. So if you don't answer the question correctly, it'll go back a few seconds and then it'll pop up the question again. You'll be able to re-answer it again. If you don't answer it at all in the required amount of time, then that's indicating that nobody was actually sitting in front of the presentation, and so it may kick you out all the way to the beginning. You'll have to start all over. So keep that in mind as we're going through this. And this is a required section, as I spoke about just a second ago. So once this is actually completed, when you're finished, if there is another required presentation, it'll pop up. For instance, this is a 2-hour presentation. If this was part of a 4-hour presentation, you'd watch this 2-hour segment, probably take a break, maybe take a day off, something like that. But when it's done, you would actually see your next 2-hour presentation or hour presentation, whatever the case may be, would be available for you to take it at that point. These are only available when the required presentation before it, if there is one, has been completed. So once this is done, either you're going to see another presentation that will pop up if you're expecting longer duration, or you'll see a question and answer section that will pop up. That's a requirement in order to get your CEUs for pretty much every state. So when that pops up, you'll want to click on the question and answer the questions. When that's finished and you've got it all completed, next your certificate will pop up in the student catalog screen where your courses are at. With that, you're going to be able to print your certificate, or you'll be able to save your certificate, or both. I'd recommend doing both, because if you lose your certificate after you print it out, there's nothing to say that you've gone to this class on your end. Now, on my end, I log it. I'll send the information to the state, but you're going to have to renew your license. So save it to your computer to make sure that you always have a copy of your proof that you attended this class. So everything happens in sequence. First, you take all the presentations. The maximum amount that I'm ever going to give you at one particular time is 2 hours. So if this is a 2-hour presentation and you're expecting 2 more after this, then when this is done, you'll be able to either take a break or log out and come back to the next section later, but the next section will pop up. If you're not expecting any more classes after this one or any more hours after this 2-hour section, then questions will pop up. You'll have to answer the questions. After the questions are answered, your certificate will pop up. You can print it off and save it. And then after that, the course is completed. It logs it to me, it sends a course completion verification to you, and then it also will be logged with the state through me. So that's your sequence of events that we're going to go through here. Enjoy the rest of the presentation. Again, the understanding part 2 will cover roughly chapters 5 through 7, but a very, very small section at the end with chapter 8 as well. So, with that being said, we're going to go ahead and forge on. Understanding the NEC, Part 2. Chapter 5. And remember in Chapter 5 that we're starting our special circumstances. However, if when you're in chapters 5, 6, and 7, you don't have any references to some of the things you learned in chapter 4 or any modifications, then all of the first chapters still apply. The purpose for chapters 5, 6, and 7 are to simply go back in and modify the first 4 chapters if it's applicable to fit a certain circumstance or application. Chapter 5, Special Occupancies. Special occupancies are fairly straightforward, and they may be a little bit difficult to comply with, but their basic purpose for the way they want things installed is pretty straightforward. Special occupancies are an area where, because of the environment, proximity to a certain environment or people, or numerous other factors, contribute to the products or the methods by which they're installed, they require special concern. Remember that when we're talking about special occupancies, not all the information derived in the NEC comes solely from the NEC. They know that there are other industry leaders in this area, and they draw from the NFPA Articles 497 and 499. 497 is the recommended practice for the classification of flammable liquids, gases, and vapors, and hazardous locations of electrical installations in a chemical process. 499, NFPA 499, is called recommended practice for the classification of combustible dust and of hazardous locations for electrical installations in chemical process areas. So let's dig into Article 500, hazardous locations, where we're going to talk about areas where fire or explosion hazards could exist because of the flammable gases, vapors, combustible liquids, or combustible dusts, or fibers could occur. 500.1, the scope. Now remember, anytime you see the word scope in these code books, the word scope is indicative of an overview of a chapter. So 500.1 deals with the scope of Article 500. Articles 500 through 504 cover the requirements for electrical and electronic wiring and equipment for all voltages. In Class 1, which is flammable or combustible gases, vapors, and liquids, Class 2, ignitable dusts, and Class 3, ignitable, but usually not explosive, fibers and fines. So let's look at those individually. And the first thing we're going to look at is Class 1. Flammable or combustible gases, vapors, and liquids. The groups that are covered are groups A, B, C, and D. Group A deals with acetylene, B, hydrogen, C, ether, and D, hydrocarbons or fuels and solvents. Now, keep in mind, as we go through the hazardous locations, there are several different terms that I'll use, and they're fairly easy to keep separated, but it's worth noting at the beginning here that you're going to run into classes, which basically tell the type of the danger, whether it's combustible gases or combustible dust or something like that. And then the groups, which narrows down to the specific type of danger, the very specific type. And then you'll also see divisions. Divisions are basically indicative of how dangerous is it. Is it there all the time? So you've got suspended vapors or dust in the air, so we always have a fire explosion hazard? That would be Division 1. Or is it normally contained and usually does not present a danger, but the threat is still there in the case of an accident or a breakdown, like in Division 2. So Division 1, normally explosive and hazardous. Division 2, normally not in explosive quantities for a Class 1 type of scenario. Class 2, ignitable dusts. The groups that you'll see covered here are Group E, metal dusts. Usually you're going to see electrically conductive and explosive flakes of metal. Group F, carbon dusts. And Group G, flour, starch, grain, combustible plastic, or chemical dust. So in this class of ignitable dusts, you've got Division 1 and 2. Division 1, you're going to have normally ignitable quantities that are suspended in the air. Division 2, normally not sufficient suspended quantities to ignite. However, accidents could happen because the dangers obviously still exist. Class 3, fibers and flines. Okay, generally here, the dust that we'd be talking about would fall into the group that best typifies the chemical makeup of the dust. So you may actually have to go into the NFPA articles that we had spoken about earlier, which are NFPA 497 and NFPA 499, to figure out exactly which types of dusts that we're talking about. But the groups that are covered here usually deal with textiles and woodworking. They're easily ignitable, but not likely explosive. And here your Division 1 means it's handled or used in manufacturing. Division 2 means it's stored or handled in storage exclusively in manufacturing. So you'll remember your Division 2, accidents could happen because the danger is still there, although it's a diminished likelihood that it would happen. So your divisions versus classes. Divisions versus classes. You've got your classes that are going to name the type of danger. Your divisions are going to tell how much danger is present, as we spoke about earlier. Division 1's the most dangerous. Danger is always present. This is going to be your most expensive area to install anything because it's going to have to be the safest devices that are out there. Division 2, it's still dangerous, but the material's normally not in enough quantities to be dangerous. So the danger is still present and could pop up in the accidental situation, whether it's a breakdown or a spillage or something like that, but normally the danger is contained. And it's also usually got a secondary approach to safety, which deals with positive mechanical ventilation to keep the Division 1 components out. And remember, your groups are divided into A through G for the gases and vapors and liquids and dusts and all that kind of stuff, which we just spoke about. They're located specifically in Class 1 and Class 2 when you're talking about A through G. And Class 3 dusts are going to be a little bit more complicated. So that group is going to have your assignment based on the type of chemical dust makeup. And one other thing that's important to review right here is you can install a Division 1 piece of equipment in a Division 2 space, because Division 1 is going to have all of the most strict safety requirements, which makes it most expensive. So those devices are going to be able to be installed in the Division 2 area, even though you probably wouldn't install them in those areas unless specifically asked to by an AHJ. Division 2 locations would generally not be able to, or Division 2 approved items would not be able to be installed in Division 1 area most of the time. We'll look at our first device right here, 500.2. We'll look at a couple of definitions. Dust ignition proof. It keeps dust from getting in and heat, arcs or sparks from getting out. Pretty simple. Dust ignition proof equipment been enclosed in a way that keeps dust from getting into the inner components and doesn't allow any of the other stuff to get out. So you'll notice there the red label that indicates that it's dust ignition proof, and also will indicate what location or temperature rating that can be installed in as well. Dust tight. Dust tight is constructed so that it'll keep dust out. It's as simple as that. It doesn't have anything to do with arcs and sparks. It just simply is designed to keep dust out. Hermetically sealed. Completely sealed from the atmosphere, usually done by fusion or brazing or welding. In the mechanical side of things, one general way to tell that something is hermetically sealed is that it does not come with any kind of taps on there for you to work on it from the factory. You would have to add those taps. Usually you're going to see equipment that is 5 pounds or less be hermetically sealed on the mechanical side of things. Non-incentive circuits. Big word. Worth talking about. Might spark under normal operating conditions, but it might not release enough energy to cause ignition. However, the circuits may contain enough energy for potential ignition if the equipment and the process fails. So it's not completely foolproof. Non-incentive component. It may spark under normal operating conditions, but it must not release enough energy to cause ignition. The housing of the non-incentive component is not intended to keep out flammable atmospheres for this reason. 500.3 Other articles. Unless modified in Chapter 5, all installation requirements that you find in Chapters 1 through 4 still apply. It's worth continuing to note that. Just because we're not in Chapters 1 through 4 anymore, and we're in the 5 through 7, which is basically there to modify Chapters 1 through 4, if it's not mentioned or modified in these chapters, the first 4 chapters still apply. Combustion principles. If we're going to talk about combustion principles and really break it down, we're going to have to talk about what it takes to actually create combustion. Okay, which is fairly simple. Some people overcomplicate this and make it really difficult. Some of these fire triangles, is what they're called, will have 20 or 30 different layers. Now, in reality, as tradesmen, we know that it takes a certain mixture, fueled air mixture, in order for combustion to happen properly. Okay, but there are all kind of variances, plus and minus, that the combustion can still happen, but not be complete combustion. It could be dirty combustion. So we're going to look at this very simply, and we're going to say that in order for combustion to occur, we have to have a fuel. We have to have some sort of fuel, right? And our potential fuel types that we're talking about here deal with our classifications of hazardous locations. That's what we're talking about. So we could have combustible fuels, which oftentimes we're talking about natural gas or LP gas, especially if we're talking residentially speaking. But then we could also be talking about grain dust or textile dust. Okay, and those would have to be suspended in the air in sufficient quantities to create a hazard. So in order to have combustion, we also got to have enough air. And I have to have a good fuel to air ratio to support that flame. So if you're going to measure the air, especially in a combustion scenario, you're going to have to know what you're starting with in order to know what you're supposed to end up with. So in the air that we breathe, it's not rocket science. We don't have 100% oxygen in that air. What we have is 78% nitrogen, and under normal everyday circumstances, at what's considered a low temperature heating point below 2000 degrees, nitrogen and oxygen oftentimes will not have any kind of chemical reaction, and so the nitrogen will pass through the combustion process unscathed. We have roughly 21% oxygen, so nowhere near 100% in the air that we breathe. Any combustion that we have is going to diminish that. It's going to use that oxygen up, create chemical reactions and such that are going to make it so it's not pure oxygen that we can use anymore. And then, of course, 1% is considered other gases, things that are basically non-conducive to the situation. They have no bearing either way. And then we've got our fuel types. We've got our air. We have to have something to start the fire, right? So we got to have some sort of a heat or ignition source. A heat or ignition source could be as simple as an open flame. Somebody smoking a cigarette or lighting up a match or a lighter. It could be just an incendiary flame that we've got going on. It could be a spark from contacts making in a relay or on a contactor or a motor starter or something like that. Or it could be basically a friction spark, a static spark. And then we also could have pressure. At this point in the game as tradesmen, most of us understand the game that we're playing, and that game involves manipulating pressures and temperatures. If you can manipulate something to the point in which the pressure goes up, when the pressure goes up, the temperature goes up, which allows you to control the combustion process. 500.5a, classification of locations, deals with where everything's going to be put. That's really what it comes down to. Classifications deal with human safety, but also it deals with what products are going to go into those locations to keep that human safety going. And obviously we don't want the building to burn down either, but that goes along with it. Human safety's got to come first. So the main thing is, in order to reduce the expensive equipment and wiring methods that would have to go in Division 1 locations, always know where that brake line is in Division 1, Division 2, so that you can install as much as possible out of the Division 1 location and in the Division 2 or beyond locations. They can communicate but it would save you a boatload of money and ease of install if you can keep it out of there. 500.5B, Class 1, flammable or combustible gases, vapors, and liquids, which is Class 1. Again, the groups that are covered are groups A through D: acetylene, hydrogen, ether, hydrocarbons, fuels, and solvents, some of the more popular ones that we've heard of, common terms. Remember, in Division 1, in Class 1, we're talking about the flammable or combustible gases. The basic difference there is uh, your flash point. Flammable is going to be below 100 degrees, and combustible is going to be over 100 degrees for your flash point. That's all it is. Flammable or combustible gases, vapors, or liquids. Division 1, normally explosive and hazardous. Division 2, normally not in enough quantity to explode. Hazard's still there, normally not in this sufficient quantity. 500.C, Class 2, ignitable dusts. Ignitable dusts cover groups E through G, some of the more common ones. Metal dusts, electrically conductive and usually explosive. Carbon dusts, flour, starch, grain, combustible plastic, things like that for group D. Example here would be, for instance, I know of a tortilla factory, and at least some of the areas there are Division 1 or Division 2 Class C locations. Remember, the divisions for Class 2 deal with the amount of dust that's actually suspended in the air normally. So Division 1 is normally ignitable quantities suspended. So there's enough there, and there's a good enough fuel to air ratio that we could have an issue. Division 2, normally not enough suspended quantity for an accident to happen. Could happen, but normally not enough there. And then 505D, Class 3, which are your fibers and flyings. Usually, when it comes into Class 3, oftentimes the groups that are covered are going to be textiles and woodworking areas, but there's no specific group. You're actually looking for the classification or chemical makeup of the dust in order to tell what the actual ignition qualities are of these. So it's actually a case by case basis in the textile and woodworking industry. Remember, here, instead of having gases in the air or dust in the air, now we're looking at where are we doing the textiles and woodworking. Division 1 is when it's being handled or used in manufacturing, and Division 2 is it's being stored or handled in storage exclusively in manufacturing. So still could have the accidents because the danger is still there, but it's more unlikely that you won't. 500.6, looking at the material groups, again, Class 1 groups out of 500.6A were groups A through D. Okay, some of the examples: acetylene, hydrogen, ether, and propane. Class 2 groups out of 500.6B are basically groups E through G, which include metal dust, electrically conductive and explosive, carbon dust, similar to coal, and flour, starch, grain, and combustible plastics would be your group D. Excuse me, G. 500.8, equipment. Article 500 through 504 require special equipment for special circumstances. So safety can be maintained to people and, of course, to the property as well. 500.8A deals with the suitability of that equipment. Suitability of equipment shall be determined by one of the following. One, this would be 500.8A1, the listing and labeling. Two, the evidence of compliance by a qualified testing agency. Three, any other evidence acceptable to the AHJ, such as manufacturer testing. Or potentially it's a product that you've asked for special installation provisions from the inspector, and he said, okay, if you get a third-party testing agency and they come back with findings that are acceptable to me, I'll let you put it in. Those findings would be something that would be acceptable in this category 3. 500.8B3, hazardous approvals. Where allowed in 501 through 503, you can have general purpose equipment or equipment in general purpose enclosures in Division 2 locations, providing the equipment normally does not constitute a source of ignition. And here's some examples. 500.8C, markings. Unless you see an exemption in 500.8C6, all equipment going into hazardous locations have to be marked to show the environment that they've been tested for, including C1 through 5 here, classes or the class, the division, only if it's for Division 2 only, material classification group, its equipment operating temperature rating of 40 degrees Celsius or higher, or ambient temperature rating if less than negative 25 degrees Celsius or greater than 40 degrees Celsius. Now let's look at a couple of those. C2, where we talked about division and only if it's for Division 2. If the equipment is suitable for Division 1, then you can omit the division label because it's automatically allowed in Division 2. C4, the temperature rating of higher than 40 degrees Celsius. For Class 1 and 2 locations, the temp rating's got to be based on the maximum temp that the equipment could run at. If it were running with the maximum amount of dust it could possibly accumulate. The label shall have the temp ratings from the table at 500.8C, which uses what's called T codes. And C5, talking about the temperature rating again, markings have to be in Celsius. So you've got to make sure that you've got your positive and negative rated in Celsius on these labels. It's a universal label. .8C example. Okay, here's your example of a label. Okay, notice we've got our classes, divisions, groups. You also have your T codes on the far right with the C next to them for your Celsius label. And then you also see the listing marks on here. That 500.8C classification of maximum surface temps, I thought it would be prudent to go ahead and put this table on here so that you could see what those T codes actually are and what they relate to. So you notice they've got the Celsius marking and the Fahrenheit marking, which you might find on the label. But the Celsius is going to be your mandatory label that you're going to see pretty much on all labels. 500.8E 1 through 3 deals with threading. Pretty simple concept. Threaded entries into explosion-proof equipment shall be made up with at least 5 threads fully engaged if it's standard threads, or 8 threads fully engaged for metric threads. And all unused openings have to be closed with a listed metal close-up plug. 500.9 specific occupancies. Okay, there are tons of specific occupancies that are dealt with in Article 500. 500.11 deals with garages, repair, and storage. 513 aircraft hangars. 514 gas stations, motor fuel dispensing facilities. 515 bulk storage plants. 516 spray booths, spray applications and coating. 517 healthcare facilities. That's a real major one. If you work in healthcare facilities, you'll want to pay special attention to that. It seems to me, just my own opinion, that anytime you're working in a healthcare facility, you're always going to be following the most safety rules that you could possibly have. 518, assembly facilities like gyms, auditoriums, conference rooms, and restaurants, all examples given by the NEC. Article 550, mobile homes, manufactured homes, and mobile home parks. 550.1 covers the scope. Article 550 covers the conductors, equipment within or on a mobile and manufactured home, and conductors that connect mobile and manufactured homes to their electrical supply. 550.2 definitions. Got a big one right here. Manufactured home. A structure that is built on a chassis and designed to be used as a dwelling unit with or without a permanent foundation. So some folks decide, in their own head that, hey, that's not a manufactured home if it's got wheels on it. Well, that's not necessarily true. There are other provisions here. I have met people that have a manufactured home on a foundation and still have the wheels downstairs in the basement. So the wheels really have nothing to do with whether or not it's considered to be a manufactured home. Okay, so it could be with or without a permanent foundation. There are other provisions. Like I said, it must be at least 8 feet wide and at least 40 feet long, or at least 320 square feet. Those are all parameters given in the code. However, for the purpose of the article we're talking about here, the term mobile home includes manufactured homes. Okay, and there are lots of different examples that we've got. This one here is beautiful. I would never have guessed that that was a manufactured home. 550.4 general requirements. Hey, remember, when we're speaking about general requirements, these are things that apply throughout this entire section, this whole article, unless they're modified someplace else. So 550.4a, mobile homes not intended as a dwelling unit. Well, what would you be talking about here? Well, probably the most common would be a job site trailer. A mobile home not intended as a dwelling unit isn't required to meet the 100 amp minimum circuit capacity requirements of 550.32c for a dwelling unit. Okay, and you'll see that picture down here below. .4b. What happens if a mobile home or a manufactured home is not actually in a mobile home park? Does it have the same compliance requirements? Mobile homes installed in some place other than mobile home parks shall comply with this article. So, pretty straightforward. Article 550.12, branch circuits required. You might be surprised to learn that the requirements in a mobile or manufactured home mirror the traditional homes. So let's look at those real quick. The lighting, same calculation found in Annex D. 3 VA times the square foot of the home divided by the voltage. Right? So that's your lighting calculation. Your small appliance circuit, you got to have two or more of those. They got to be 20 amp, 120 volt. You have to have one laundry circuit, 20 amp, 120 volt. When it comes to general appliance, if your appliance is cord and plug, normally what we're talking about here, fixed in place with a light or other receptacle on that circuit, you can only pull up to 50% of that circuit's load. Remember, that's the appliance and you've got other things on that circuit. Now, if the appliance is fixed, but there is no other receptacles or lighting on that circuit, you can pull up to 80% of the circuit load. And then also, if you've got a cord and plug appliance that's not fixed in place, so you can move it around, you can also pull up to 80% of that load. When it comes to bathrooms, you got to have at least one circuit, 20 amp, 120 volt. And again, just like in traditional homes, you can't serve other rooms with that bathroom circuit. Worth remembering. 550.13, receptacle outlets. This section is going to cover types of acceptable outlets and, of course, their installation requirements. So, let's look at them. A, 550.13a, grounding type. All must comply. It's the receptacles have to be of the grounding type. They have to be installed according to 406.4, and they have to be a 20 amp or 15 amp 120 volt circuit unless it's to a specific appliance, and then it can be slightly different depending on the appliance. So we mentioned 406.4. Let's take a little bit closer look at that. .406.4, general installation of receptacles. Now, these requirements, again, the command in the code is shall be done in accordance with Part 3 of Article 210. But again, we're talking about Section 406.4. So 406.4a talks about grounding type, and it says for what you find, except what you find in 406d, all 15 and 20 amp branch circuit receptacles shall be the grounding type. And 406.4b says that receptacles as well as cord connectors that have equipment grounding contacts must be connected to an equipment grounding conductor. Pretty straightforward. And 406C basically lines out what your methods of groundings are. The equipment grounding conductor of the receptacle and the cord connectors shall, again, that's not a choice, that's a command in the code, be connected to the equipment grounding conductor of the circuit that is supplying the receptacle or cord connector. The branch circuit wiring method shall provide an equipment grounding conductor for that receptacle. Period. That's 406.4c, methods of grounding. Not a lot of rocket science, but definitely not a lot of wiggle room. 406.4d, replacements. They must be done in accordance with 4064D 1 through 6. Arc fault and ground fault receptacles shall be installed in readily accessible locations. Remember, it doesn't mean that it has to be a receptacle when we're talking about it in the code. Okay, but if we're using receptacles, they have to be in a readily accessible location. So, again, replacements. Grounding type. If there's a grounding means in the receptacle enclosure already, you have to use a grounded receptacle in the replacement. It's as simple as that. 4064D2 talks about non-grounding type. If there's currently no grounding conductor in the receptacle enclosure, you must comply with A, B, and C. And what they say is non-grounding receptacles can be replaced with another non-grounded receptacle. Okay, so that is still okay. Okay, because if there is no ground wire in there to hook up to, and you're not going to be required to run a new one in this particular instance, then you can replace it with what's there. Non-grounding receptacles can be replaced with a GFCI receptacle as long as it's marked no equipment ground. And C, non-grounding receptacles can be replaced with a grounding type receptacle that is supplied through a GFCI and marked, again, exact words in the code, no equipment ground. 4064D3, GFCIs shall be provided where required elsewhere in this code. So what's the exception here? Where the enclosure will not fit, it physically does not allow the girth of a GFCI receptacle. You can put a new version of the existing receptacle where GFCI is already provided and the receptacle is marked both GFCI protected and no equipment ground. Okay, so if you have the GFCI protection and you're replacing a receptacle with a non-GFCI protected receptacle after the fact, you're going to have to label that as well as the no equipment ground. 4064D 4, arc fault circuit interrupters. Where AFCI is required, the replacement should be done with one of the following: a listed AFCI receptacle, a receptacle already protected by a listed AFCI receptacle on that circuit, or 3, a receptacle protected by an AFCI breaker. And remember, some folks forget that this was not immediately effective in the code because the arc fault breakers had only newly become available shortly before, and still many of them were in the testing process. So this particular section of the code actually became effective on 1/1/2014 according to the National Electric Code. Now if you're not believing me, we're talking about the 2014 code, and if you go to page 282, not the handbook, the actual code, it actually will tell you on page 282 this very information. 406.4D 5, tamper resistant receptacles. They must be provided where required by the other sections of the code. Okay, remember 406.12 is an other section of the code, and it says specifically for tamper resistant receptacles, tamper resistant receptacles shall be installed in accordance with 406.12 A through C. So let's look at those. 406.12 A, dwelling units. in all areas specified in 210.52 that have 15 and 20 amp 125 volt receptacles, you shall use listed tamper resistant receptacles. Hey, not a whole lot of rocket science there. So everything that's in 210.52, whether it's, A, uh, section A is going to be pertaining to a lot of this as far as the headache, but the countertop receptacles, of course, are going to create a headache as well if you're not used to this. But everywhere in a dwelling unit that requires receptacles in 210.52, got to have tamper resistant receptacles. 550.13b, GFCIs. All 15 amp and 20 amp 120 volt receptacles that require GFCIs in a mobile or manufactured home are ones installed outdoors in compartments that are accessible from outside, bathrooms, in luminaires, lighting fixtures, kitchen countertops, or within 6 feet of a sink. 550.13f, receptacles not permitted. Hopefully, according to this picture, you are making the assumption that this one is not permitted. If you were the one that was looking at this trying to figure it out and can't really figure it out, maybe we better go back to the drawing board. 550.13 F1, no receptacles over or in a bathtub or shower. 550.13G, also speaking about receptacles not required, G2 says in the wall space behind doors that can be opened fully against a wall surface. So remember, we're in Article 550 here. We're not in a traditional home. We're talking about mobile homes. So if a door can be opened completely flat against a wall surface, so the interpretation that I've had from several of the code officials have said, if you have a door that basically has a little button hook opener, you don't have an actual handle on there, and it can open up against a wall completely flat, then they don't want a receptacle back behind that door. It also could be a door that when it opens up, the knob actually opens up into part of a closet opening, which allows the door to completely sit against that wall flat. 550.16, grounding. Grounding of the electrical and non-electrical metal parts in a mobile home shall be through a connection to the grounding bus in the mobile home panel board. The frame of the mobile home nor the frame of any appliance shall not be connected to the grounded circuit conductor of the mobile home. Okay, surprise, surprise, that we have a lot of the same principles at play when it comes to mobile homes. 550.25b, arc fault in mobile and manufactured homes. 15 and 20 amp 120 volt receptacles in these areas require arc fault protection. It's going to surprise you, but it's exactly the same as what a traditional home is. Remember, just because the dwelling unit is a little bit different doesn't mean that we diminish the safety of the dwelling unit. We're still concerned about people and property. 550.32, service equipment. 550.32a, the mobile home disconnect. A disconnecting means must be located adjacent to, here's that within sight from that we talked about in some of the earlier definitions, but not more than 30 feet from the exterior wall of the mobile home. So oftentimes it's going to be out in the yard, but remember, it's got to be adjacent to, in sight from, so we're not talking on the other end of a forest or the other side of a fence or something, but not more than 30 feet from the exterior wall of that mobile home. Okay, when it comes to manufactured homes, they can be located on the outside wall of the structure, just like a traditional home. You have a minimum ampacity of 100 amps, and it has to be 120 240 volt service. So one thing that is, in addition to this, worth noting, that there are height requirements for this as well. And the height requirements come in F. So 550.32F say that the height requirements for the service disconnect cannot be any lower than 2 feet from grade or any higher than 6 feet 7 inches from grade when the disconnect handle is in the highest position. So remember, you have a height requirement, okay, and this goes on the side of the home when it's mounted there for a manufactured home, but also we're talking about mobile homes that traditionally have these service disconnects mounted on a pole or something similar. It's got to be between 2 feet off the ground and 6 feet 7 inches off the ground. Article 590, Temporary Installations. 590.1 is the scoped Article 590, and it tells us that you're going to find in this article the temporary power and lighting requirements for emergencies, tests, renovations and construction, as well as, surprisingly enough, holidays and special occasions. 590.2, all installations. Okay, when we're talking about all installations, this is your baseline. This will apply to all of your temporary installations unless modified. So 590.2A deals with other articles. All requirements of the National Electric Code apply to temporary installations unless specifically modified in this article. So a lot of people look at temporary installations and think that they can go ahead and throw whatever together works and it'll be good enough. In reality, that's not true at all. All the requirements that are there in the code are still there in the code, even though it's just for a temporary installation. So it's very important to remember that going forward, so that way when you're dealing with this stuff out in the actual field, you're taking life safety into account. 590.2b, approval. Temporary wiring methods are acceptable only if approved based on the conditions of use and any special requirements of the temporary installation. So, when it comes to approval, who do you suppose has the ability to approve and not approve this stuff? Exactly. Your authority having jurisdiction, your inspector. Hopefully all of your installations look just this nice, but chances are not everybody's does. 590.3 deals with time constraints. So time constraints generally are referring to how long you can have these temporary situations sitting there. And 590.3a talks about that durational period. Temporary electrical power and lighting installations are only permitted during the period of construction, remodeling, maintenance, repair, or demolition of the buildings, structures, equipment, and similar activities. When the construction is done or the temporary scenario has been remedied, so now it's a permanent scenario, all the temporary stuff's got to go away. The approval's over at that point. 590.3b deals with holiday lighting as well. It says you only have 90 days to keep up holiday lights. So for some of you folks that keep your holiday lights all stapled up all year round, in your area, chances are if you've always done it, your inspector's fine with it. However, if you read the code as is, in a very direct approach, you would see that it says very clearly that that's not allowed. And the interpretation also goes a little bit further and says you can't just unplug them. You have to take them down, which is, obviously adds a lot more to the job if you don't just unplug them. 590.3 dealing with time constraints in section D, removal. Temporary installations must be removed immediately when the temporary situation that you were using it for been taken care of. And we see this kind of stuff all the time. Maybe not this particular kind of stuff, but we see temporary installations all the time. Some may be a little bit worse than others. 590.4 General Requirements. Okay, keep in mind that everything in the first 4 chapters of the NEC are going to apply to temporary installations unless they're specifically modified. One of those sections is GFCI. You still have to have ground fault circuit interruption protection and also your protection for personnel in place as well. That still applies even though it's a temporary scenario. 590.4 General Requirements. 590.4C deals with branch circuits. Okay, remember we're talking about temporary power and lighting. So this is dealing with temporary scenarios. All branch circuits still have to originate from an approved power outlet, panel board, or enclosure as well. So for this section, you'll also see that non-metallic cable like Romex should be able to be used with no limitation for height or construction type and doesn't have to be concealed in walls, ceilings, and floors. So if you're wondering why you see your basic non-metallic cable used on job sites for temporary scenarios, it's because its limitations are a lot less than some of the other types of wiring methods that you could use. Okay? And plus, just all around, it's quicker and easier to use. 590.4D1 talks about receptacles. All receptacles shall not be on the same circuit as temporary lighting on a construction site. Shall not is a huge saying there. So what they're telling you is you cannot put receptacles on the same circuit as temporary lighting on this construction site. And they've got to be connected to an equipment grounding conductor so that the overcurrent device, like the breaker, is going to trip properly. And they have to be GFCI protected. So in brief overview on this one little important section here, it tells us that you could GFCI protect the lighting circuit if you wanted to. There's nothing that prohibits you from doing that. However, you're not killing 2 birds with 1 stone, meaning putting the lights and receptacles on the same circuit and GFCI protecting it all so you run less wire. You're not allowed to put the receptacles on the same circuit as the lighting. So oftentimes you're seeing folks that will run the lighting separate, of course, and not GFCI protected while running the receptacles on a GFCI protected circuit because that's actually required. 590.4F says your lamps have to be protected, right? And that's a shall statement. Lamps shall be protected from accidental damage by contact with the use of a lamp holder with a guard. 590.4G talks about splices. No boxes are required for splices or junctions on a construction site as long as the equipment grounding continuity is maintained. So, we don't have to necessarily follow all the same principles because this is one section that's modified a little bit. We don't have to have the splices inside of a box as long as its ground is maintained and the method that you've used is giving it proper insulation and personnel protection as well as being suitable for the environment that it sits in. 590.4H talks about protection from accidental damage. Cords and cables shall be protected from damage. We're talking about rollover damage as well as sharp corners, vibrations, heat, all that kind of stuff. And there's some pretty ingenious ways that folks do this. Some of these products are really pretty cool. They work well, they're durable, and they also look pleasing on a construction site. They don't make it look all bulky and as much of an eyesore as what you would think. 590.4 general requirements in I. Termination at the devices. When terminating flexible cords and cables in a box, they have to be secured with fittings listed for that purpose. .4J. Supporting. Cable assemblies, flexible cords should be supported and spaced appropriately for the location to ensure that there's protection from physical damage. Okay, the support, of course, is going to be determined by your local inspector. There's not a lot of guidelines in the National Electric Code, okay, but there are job site conditions that are outlined in 590.2B. And it's also important to remember that new to the code in 2014, extension cords do not apply to this rule. .590.6 ground fault protection for personnel. All temporary wiring supplied that can be used by personnel, by people, shall have ground fault protection. It doesn't matter whether the power is derived from the power utility or if it's site derived, like solar or gas powered generator. Makes no difference. You still have to have GFCI protection for personnel. 590.6A1 receptacles not part of the permanent wiring. So we'll look at this in a little bit more depth. All 15, 20, and 30 amp 120 volt receptacles used by personnel shall have GFCI protection. Listed cord sets that have integral GFCI protection are allowed. So this is one area that's modified as well, above and beyond what Article 210 talks about. It says that all 15, 20, and 30 amp receptacles. So it used to be 15 and 20 amp in just a general sense for residential dwelling use. Now we're talking about 30 amp as well. 590.6A2 receptacles existing or installed as part of permanent wiring. This portion here may be easier described as permanent receptacles used as temporary power. All 15, 20, and 30 amp 125 volt receptacles that are existing in the structure and may be used even if temporarily for power during construction by personnel shall have GFCI protection. Listed cord sets that have an integral GFCI protection are allowed. Now we're talking 590.6A3 receptacles on 15 kW or less portable generators. Again, 15, 20, and 30 amp 125 volt receptacles on portable generators up to 15 kW in size shall have GFCI protection. Again, listed cord sets that have integral GFCI protection are allowed. Now we'll move on to a completely new section. A completely new section for us in this presentation. It's obviously not new in the code. However, this is a largely expanded section in the 2014 code book. Article 625, Electrical Vehicle Charging Systems. 625.1 deals with the scope, the general overview of this section. This article covers the installation and safety related to the equipment and devices related to electric vehicles. 625.2, definition of an electric vehicle. A vehicle that has a motor primarily powered, not completely powered. Okay, it could be, but it doesn't have to be. It says primarily powered by electricity and is for on-road use. These include automobile, bus, truck, van, neighborhood vehicle, and motorcycles. Right? There's some pretty cool ones out there. The industry's come a long, long ways. (625.5) having things listed or labeled. All electrical materials, devices, fittings, and associated equipment must be listed or labeled for the purpose. Part 2, the equipment's construction. 625.10, electric vehicle coupler. Okay, this is the actual section where we talk about hooking up the electric vehicle for charging purposes via coupling unit to the charging device or the power supply. Electric vehicle charging coupler shall comply with 625.10 A through F, and they are polarization. Coupler must be polarized. B, non-interchangeability. Coupler cannot be configured in a way that allows it to be wired in and used on other electrical systems. It doesn't say that it can't be used on other electric vehicles other than yours, but it says it can't be used on other electric systems. Construction and installation. It shall be made and installed in a way that prohibits inadvertent contact between live parts and people. Unintentional disconnection. It must have measures that prevent accidentally being disconnected. And we're continuing. E is grounding pole. It must have a grounding pole integrally or set up as an isolated system. And the grounding pole requirements say that the grounding pole has to be set up or constructed so that it makes contact to the equipment first and breaks contact first as well. 625.15, more particularly Section B, ventilation not required. Mechanical ventilation is not required for electric vehicle storage batteries or equipment where it has been listed or labeled as suitable for charging electric vehicles indoor without ventilation. The equipment has to be marked, clearly marked, stating ventilation not required on the device. It shall be visible even after installation, and that's a code requirement. Okay, primarily what we're looking at here is, there are some batteries that while being charged, they put an off gas into the surrounding environment. And of course, if there's an off gas in the surrounding environment, it could be dangerous to humans, or even be flammable or explosive, dangerous to the surrounding structure, and so ventilation would be required. If that's not the case, then it would not be required, but it has to have the clearly marked label stating that ventilation is not required. And then 625.15 C, dealing with ventilation required, is the same thing. Okay, if the supply equipment is listed or labeled as suitable for charging electric vehicles that require ventilation, the ventilation must be included. Okay, and it has to be clearly marked, according to code, as ventilation required, those exact words, and it's got to be visible even after it's installed. (625.17) Cords and cables. 625.17c more particularly deals with the overall cord and cable length. They shall not be longer than 25 feet measured from the coupler back unless a listed cable management system is used. 625.19 Automatic de-energization. This, of course, is going to be meant to protect the people and the structure in case the cord fails and falls into a wet or flammable environment. The electric vehicle charging equipment has to automatically de-energize the connector and conductors in the case of severe strain or in the case that the cord gets pulled out. 625.22 Personnel Protection System. They shall have a means of disconnect in the cord or on the attachment plug for personnel protection. If it is in the cord, it can't be any further than 12 inches from the attachment plug. Notice the picture here. And the GFCI protection would be optimal at this point, of course, on the circuit, and it would be, certainly located inside of the attachment cord or the plug. In addition to all this, the entire circuit has to have GFCI protection. Part 3, Installation. (625.40) Overcurrent protection. Being sized for continuous duty is mentioned in this section here as well as in 625.41. Overcurrent protection for circuits supplying electric vehicle supply equipment must have a rating of not less than 125% of the maximum load of the electric vehicle supply equipment. They shall also be sized for continuous duty. 625.41 Rating. Charging loads for electric vehicles are considered to be continuous duty and is sized off of the electric vehicle supply equipment rating. 625.46 Loss of primary source. This section is pretty easy. If you lose your primary source of power that's feeding the charging equipment, you certainly don't want the power to start feeding backwards from the car through the charging equipment into the circuit in the house. That's all we're talking about here. 625.50 Location. What about the height requirement? The coupling means the electric vehicle supply equipment must be located at a height of not less than 18 inches and not more than 4 feet above the floor. So we're talking the coupling means has got to be in that range. So between 18 inches and 4 feet above the floor. Location. The electric vehicle supply equipment must be located so that it permits direct connection from the vehicle connector to the electric vehicle. Okay, obviously, no uses of extension cords or anything like that are going to be permitted. 625.52, talking about ventilation again. The ventilation not required. Mechanical ventilation not required for electric vehicle storage batteries or equipment where it has been listed or labeled as suitable for charging electric vehicles indoor without ventilation. Okay, again, it has to be marked ventilation not required. 625.52, dealing with the ventilation being required. Okay, if it's suitable for charging indoors, but it has to have ventilation, it's got to be clearly marked. Ventilation required. And again, just as before, it has to be visible even after the installation. Article 640. Moving on. Audio processing, amplification, and reproduction. 640.1 talks about the scope. And as all of the other articles, the scope covers your equipment and wiring for audio signals in a general sense. Gives you an idea of what's to be found in this chapter. Article 640 covers equipment and wiring for audio signal generation, amplification, recording, processing, and reproduction. It includes sound for public address systems and includes temporary audio systems like concerts. Some examples where you may find audio systems covered by this article would be hotels, restaurants, offices, auditoriums, churches, and schools. 640.1 B. What's not covered? It does not cover the installation of fire or burglary alarms. 640.2 Definitions. Abandoned cable. A cable that isn't terminated and isn't identified for future use with a tag. Amplifier. Electronic equipment that increases the current or voltage potential or both of an audio signal and is intended to be used with another piece of equipment. Auto transformer. A transformer with a single winding and multiple taps intended to be used with an amplifier, loudspeaker, signal output. Audio transformer. A transformer with two or more electrically isolated windings and multiple taps intended to be used with an amplifier, loudspeaker, signal output. 640.3 Other articles. Circuits and equipment shall comply with 640.3A through M. And keep in mind, penetrations have to be closed up, as though no hole was ever made. If it requires a fire stop rating prior to it, you have to make sure that it has the fire stop rating after it, because A originally begins with the spread of fire and fire products of combustion. and it says 300.21 applies. So we're talking about other articles here, and we're talking about the applicability of these specific other articles to Article 640 dealing with the audio installations and operation of equipment. So we're basically saying if you make a hole in a structure, that structure, if it required fire stop before, it has to have fire stop installed when you're done. 300.21 says electrical installations in hollow spaces, vertical shafts, and ventilation or air handling ducts have to be done so that you don't increase the flame spread potential. Pretty straightforward. B. Ducts, plenums, and other air handling spaces. See 300.22 for spaces that deal with environmental air. They shall be plenum rated unless they're installed via a wiring method accepted in Chapter 3. When it comes to 300.22b, we should probably look at that. 300.22b, wiring in environmental air ducts. Ducts that carry heating and cooling and ventilation are only allowed to have wiring methods in or through them if it's necessary to make the equipment operate properly or accessory equipment operate properly, or if the product is listed for the installation and the AHJ allows the installation. That's a two-step process. If it's listed and the inspector allows you to do it. 300.22 does have some exceptions in it. 300.22c exception allows passing through joists or studs used in environmental air. .3, still in other articles. Hey, we're going back now. We just took a look at 300.22 for a second. Okay, we looked at A and B because they were very pertinent and they were very common. Okay, the rest of these are somewhat common for some of them, and other ones are a little more obscure. So we're probably not going to look into each one of these in the detail that we did the ones before. So let's look at this. C, cable trays. You'll see Article 392. D, hazardous locations. We spoke about that just a short while ago. See Chapter 5, Article 500. E, assembly occupancies. See Article 518. Theaters, you would see Article 520. Carnivals and circuses, see Article 525. And motion picture studios, see Article 530. To continue on, I will be pools and fountains. See Article 680. J, combination systems, used when the AHJ allows the audio system to be combined with the fire alarm system. See Article 760. K is antennas. See Article 810. L, generators. See Articles 445.10 through 445.12 and 445.14 through 445.16 and 445.18. If it's a portable generator that needs to be grounded, see Article 250.34. And last but not least, M, dealing with organ pipes. You'll see Articles 650.4 through 650.8. And again, Not to diminish any of these ones we didn't go into detail in. These you can detail on your own. You should have access to this program for at least a while after you're done completing it. So you'll be able to go back and do some self-study on this. Okay, the point here was to give you some examples in the beginning, which we did in A and B, which we referenced back to Article 300 and prior to that even. So looking at this section of the code requires some finesse. I mean, we're talking about audio wiring here, and a lot of people don't know exactly what's in the code book that deals with audio wiring, let alone the amount of referencing back and forth that it takes to actually properly do it. So that's why we're talking about it right now. You have several areas that will need to be referenced in order to properly install your audio cables. Moving on to 640.5, access. Access to the equipment shall not be impaired because of panels, including ceiling panels or accumulation of wires. 640.6 deals with mechanical execution of the work. Okay, look, when you're out there on the job site and you're putting in these audio cables, it shouldn't look like you closed your eyes and threw them straight up in the air like spaghetti string. They should be put together in a neat and orderly fashion, and really the way that it ends up looking is going to be in the eye of the beholder. You're going to say, okay, this is the best that I can do, and the authority having jurisdiction has in his mind what's acceptable to the area that he inspects for, and hopefully you have the meeting of the minds. Sometimes this stuff is overly neat, and in reality, that's the way it should be. The best job we can do, best foot forward each time. So let's look at some of this stuff. The equipment and cabling must be installed in a neat and workmanlike manner. Exposed audio cables have to be supported in a way that they'll not be damaged, and by listed hangers, straps, etc. You see articles 300.4 and 300.11a for some guidance on that. Accessible areas of abandoned cables shall be removed, and cables installed for future use have to be marked with the date of identification for future use and the date of intended use and any additional information that's pertinent to the job. Six 640.10 Audio systems near bodies of water. 640.10a Branch circuit power. Audio system equipment supplied by a branch circuit shall not be located within 5 feet of the inside wall of a pool, spa, hot tub, fountain, or tidal high water mark. Also, must be GFCI protected as required by the other articles. So the other articles are still applying here when we talk about GFCI protection. Part 2. Permanent audio system installations. 640.21 The use of flexible cords and cables. Flexible cords and cables are permitted between speakers and branch circuits, between speakers and amps or just speakers, between equipment and power supplies for other than branch circuit power like transformers or storage batteries, and between racks and the premise wiring system. Okay, the requirements here also state that for the permanent audio installations, you shall comply with Article 725. Article 725 specifically deals with power limited circuits. The difference between permanent and temporary installations is that you have to take into account Article 400 when dealing with temporary installations in those matters where you're going to be taking the stuff down and moving it around. Article 400 deals specifically with requirements for flexible cords and cables. 640.22, the wiring of equipment racks and enclosure. Metal racks and enclosures shall be grounded. Whether permanent or temporary, doesn't make any difference. Okay, they don't have to be bonded if the rack is connected to a technical ground. Part 3, portable and temporary audio system installations. Boy, what a nice setup we've got here. 640.41, multi-pole branch circuit cable connectors. Some things to keep in mind in supplying power in temporary situations. Cords and cables cannot have tension on them that's transferred to the connections when connected to the equipment and powered up. It should go without saying there. The power supply cord shall have the female end connected to the load. Okay, so now we're getting a little bit more chintzy in our requirements here. We're getting real specific. The cord has to be rated in amps and be constructed so that dissimilar rated devices cannot be connected together. 640.42, the use of flexible cords and cables. Flexible cords and cables are permitted in these areas. Okay, but in looking at these, 640.42 B, C, and E all have to use extra hard usage cords or cables for the temporary use. The requirements here also state that for the permanent and temporary audio installations, you shall comply with Article 720 or 725, excuse me. Again, Article 725 specifically deals with the power limited circuits. So, looking at these, flexible cords and cables are permitted between speakers and branch circuits, between speakers and amps or just speakers, between equipment and power supplies other than branch circuit power like transformers or storage batteries, and between racks and the premises wiring. Now, where is this different than what we talked about earlier? In 640.21? Well, there are just a few really different examples, because before we were talking about permanent audio system installations in part 2 and 640.21, which dealt with very similar requirements as we're seeing here, whereas now we're not. Now we're dealing with portable and temporary audio system cables. So if this portion of the presentation seems like the same thing you just learned, remember, it's a little bit different because it's dealing with portable and temporary, whereas what we talked about just a second ago was dealing with permanent installations. Chapter 7, Special Conditions. Article 700, Emergency Systems. 700.1 deals with the scope of this chapter. This article applies to the safe installation, operation, and eventual maintenance of emergency systems for supplying power or lighting or both in a power outage. (700.2) Definition. Okay, we're going to look at the definition of an emergency system. Those that are legally required and classified as emergency by the state, federal, and local authorities. They're required to supply power and or lighting in case of a power outage. And we see these most often in public facilities, whether it be office buildings or areas that are frequented by the public. 700.3 Tests and Maintenance. To keep systems operating the way they should be, you've got to conduct some tests. Okay, so what are those tests? Conduct a witness test. Complete the test of the system by the AHJ. You've got to have them tested periodically. Those are intervals that are accepted to the AHJ. Do battery systems maintenance. Make sure the proper charging and operation of the batteries. And test under a load. Make sure that the system is tested under its maximum anticipated load. So when you're looking at this, you've got initially here in the A section, the witness test. The whole system is tested by the AHJ, and then it's got to be followed up periodically with whatever the AHJ says is acceptable for the intervals, just to make sure it's working the way that it should. And then you got to check to make sure that the batteries are still in good repair. And you've got to test it under a load. Give it the maximum possible worst situation load that it could be operating under, and that's when you want to test it. 700.6 Signals. Signals shall be provided where possible to indicate derangement, what's not working in sequence or properly. Carrying a load, that the battery is carrying the load. That is not functioning, that the battery charger isn't working properly, and ground fault, that a ground fault has occurred. And D only applies to solidly grounded Y systems, so three-phase Y systems that have more than 150 volts to ground, that have circuit protected devices rated at least 1,000 amps. So in looking at this stuff, what are we actually talking about here? We're talking about emergency systems, and we're talking about the signals. Okay, so the signals that we're talking about here are what happens when a problem occurs with your emergency system. Okay, so the emergency system, what they're saying here in the different sections, should signal you if it's not working properly in sequence. Okay, so things are out of order. If the battery's carrying the load, which means that the power has been cut, or it's failed, and now the battery is working. So if the battery is working in a non-emergency situation, or an emergency situation has occurred, but very little indication is given because of the lighting sequence, the battery carrying the load should be indicated to the people around. So you've got to have some sort of signal on that. And if it's not functioning properly, if the battery charger is not functioning, it won't charge the batteries in an emergency situation, that's going to cause an issue. So you have to know about that even when a non-emergency is happening. Okay, so general everyday business is running, it's operating, and the battery charger stops working. They should know about that so they can get it fixed before an emergency actually occurs. And then a ground fault. If a ground fault has occurred, but here, like we talked about, it's there's very specific circumstances here. A three-phase Y system, and only if you've got more than 150 volts to ground. Circuit protective devices rated at least 1,000 amps. 700.7 Signs. 700.7b Grounding. When removing a grounding or bonding connection in normal power source equipment, it interrupts the grounding electrode conductor in the alternate power source. So a warning sign has to be posted at the normal power source equipment saying, warning, shock hazard exists if grounding electrode conductor or bonding jumper connection in this equipment is removed while alternate source is energized. 700.8 Surge protection. A listed surge protective device shall be installed in or on all emergency systems. Okay, no different than most other systems. Part 4, emergency system circuits for lighting and power. These are more specific. 700.15, loads on emergency branch circuits. Emergency circuits must supply no loads other than those required for emergency use. Okay, so this is very specific in saying that you're not going to tap into the regular lighting load in order to supply your emergency load. This means no other non-emergency appliances or lighting are going to be on that load. 700.16, emergency illumination. The emergency illumination system shall include all required means of egress lighting. Okay, you'd hate to be inside the interior of a building where there's no window lighting or any kind of lighting and have to get out of that building. So what they're saying here is you've got to light the way out, the egress lighting. Exit signs and all other necessary lighting also has to be lit. It has to be designed so that any individual light failure will not leave an area that is required to have lighting dark. This also includes the area where the indoor service or building disconnect is located as well. (700.19) multi-wire branch circuits. Very simple. Multi-wire branch circuits are not allowed for emergency power and lighting circuits. Chapter 8, Communication Systems. 800.44A4, clearance. Fairly common setup that we've got here. Supply service drops and sets of overhead service conductors that operate up to 750 volts that run above, but parallel to communication service drops, have to have a minimum of 12 inches of separation anywhere. This includes the attachment to the building. Minimum of 12 inches separation, no matter where it is. The idea, of course, is to maintain enough distance that you eliminate the possibility of induction and as well nuisance interference on the communication wires. Yeah, we've all seen horror stories before of lots of different wires run lots of different places. I'd imagine that their cable reception is probably not the best in some of these environments. 800.44b, above roof slopes. You have to maintain at least 8 feet of clearance vertically above all roofs. There are exceptions. Auxiliary buildings like garages, roofs sloped no less than 4 inches by 12 inches, and overhangs on roofs. Okay, roofs that are sloped no less than 4 by 12 inches are allowed to get no closer than 3 feet. Okay, so the 8 foot is actually diminished to 3 feet. Clearances for overhangs on roofs are reduced to 18 inches as long as no more than 4 foot of communication service drop conductors pass above that overhang. 800.49, metallic entrance conduit grounding. When entering a building with communications entrance wire contained in rigid or intermediate metal conduit, the wire shall be connected by a bonding wire or grounding electrode conductor to the grounding electrode. Part 4, grounding methods. 800.100A, bonding conductor or grounding electrode conductor. The bonding conductor may be insulated or bare and must be of copper or listed corrosion resistant material. The bonding conductor shall be no smaller than 14 gauge and no longer than 20 feet. A separate ground rod for the communication system can be installed but must be bonded to the structural grounding electrode. It must be run as straight as possible and protected from damage. 800.100B1 Intersystem Bonding Termination. The ones you see here in the pictures, boy, are those nice. They're very slick looking. If the building is required to have an intersystem bonding termination, see Article 250.94, the bonding conductor for communication systems shall be connected to it. Great example. (800.100B2) has ground but no intersystem bonding termination. If the building is grounded but has no intersystem bonding termination and isn't required to, you shall connect to the nearest structural ground, grounded metal water pipe, power service accessible means, Article 250.94 for reference, non-flexible metallic service raceway, service equipment enclosure, grounding electrode conductor or its metal service enclosure, and grounding electrode conductor that's grounded to an electrode. Remember, on the water pipe, you have to have a water pipe that's in direct contact with the earth, and it has to be connected within 5 feet of its entrance into a building. So direct contact to the earth, 10 feet, but you also have to connect to it to make it a valid ground within 5 feet of its entrance into the building. Okay, and one thing that we've said as a basic underlying tone throughout all of the electrical classes that we provide is please make sure you check with your AHJ. Your inspector has to be okay with any of these means. There's some municipalities that don't require any of these or only require more than one as acceptable. 800.100B3 no ground and no intersystem bonding termination. If the building is not grounded and has no intersystem bonding termination and isn't required to, you shall connect any of the following individual grounding electrodes found in 250.52 A 1 through 4. Could be a water pipe, a metal structural frame, could be concrete encased, a grounding ring, a rod or pipe that's at least 5 foot long in direct contact with the earth, no closer than 6 feet from any other structural ground. Bonding of the electrodes, 800.100D. You have to use a minimum 6 gauge wire if bonding the communication system grounding electrode to the structural grounding electrode. Article 830, broadband. (830.100B3) no ground, no intersystem bonding termination. Requirements are very similar to the other communication wires with a couple of minor exceptions. Here's one. If you install a separate ground rod for the broadband system, it only has to be 5 feet long and ½ inch in diameter. So you don't have to maintain your 8-foot ground rod or anything like that. So when you're looking at that, you've got broadband requiring 5-foot ground rod, and you've got a DSL system that's going to require a 6-foot ground rod. and you have the normal ground rod for the structural portion of the building that's maintained at 8 feet, and you have a lightning rod that's maintained at least 10 feet. So keeping all of these straight can really be a challenge, but there are diminished amounts when no other is available.